Baiklah. Yeah.
It's coming, right?
Yeah. Huh?
Most of the sports can come to Malaysia. Actually, you didn't even know that once land is there, I have to take bus to you. Yeah. So I told him, and he said, yeah, it's okay. And then I tell him, in Kerala, there's a yo-yo bus.
Yeah.
Yo-yo bus ticket, you can just book the ticket over there, or you can just go to Easy, what? And the website, Easy Book. Over there, register, and then you can advance booking. Once you book, once you are here, you need to make sure you either choose Lakin or Tunamina. Tunamina is the best. If Tunamina means I can go and pick him up myself. Yeah, if Lakin means make sure you download the app. The other instruction I hope is okay now. Because you will be landing at around 11 a.m. I mean 5 a.m. like that. Or you can take another charter flight to some airport, which will be a little bit expensive, huh? But short journey.
Maybe what time? I mean, what time is it?
Oh, you already bought the plane already at around 8.
You know, from maybe from
KL to JP, that's the timing that I don't know. Now you can directly check to KL also. Just take taxi and come and like what? Think what this is Indonesia. Here taxi would be 10 times way more expensive than bus and flight. I know if Papua New Guinea, Indonesia, normally personal cab would be very cheap. think we set out over the thing.
No, that was.
Or the one is the same.
The training manual, you got email me?
Email. You got it here, no? Oh, okay, I can email the soft copy for this.
Okay, I think I need more practice actually. I
Oh,
know.
But I managed to find the older version one because last time my boss did conduct training for SLC500 for a long time ago,
Yeah.
2013. So this one inside the Windows they use is Windows XP. Yeah, but it's almost similar. The programming software is still the same. Okay. So
Yes.
this one, just push it off. Yeah, prepare your certificate.
Okay, thank you.
Then the graduation form. So just send it out before the class finish.
Oh, okay, thank
Okay, can we just take a picture of big one?
you.
Can we just take a picture
Oh,
of big one? Yeah. Just do we get together? I mean, stand there.
Oh,
Yeah.
Just do this for marketing purpose.
Oh,
Yeah, don't worry. I will when I do it for marketing reason, I will make sure your name and IC all are censored.
yeah.
Yeah. Privacy is very important for me. So no worries. One more. Yeah. Okay, good. Thank you very much. Yeah, okay. Yeah, around 12 p.m. whether you receive the digital copy of this.
Oh, okay. Today I also just finished Siemens training. TIA Porter 18,
Oh,
5 days also.
where?
Huh?
Where?
Singapore.
Oh, in Singapore.
Yes, Singapore Siemens.
Oh, Singapore. Oh, 5 days training.
Yeah.
What they teach?
S7500 using
TIA.
TIA Porter, how to configure, do the simple program logic, and some simple one using the cybernetic touch, HMI, do some configuration.
They teach these drives? No.
This one is a level 2.
Oh.
They got level 1 and level 2.
Oh.
Yeah, I attend level 1 only because not easy. They need to pass the assessment teaching. because we claim like Singapore HDIF. It's not HDIF lah, it's like Singapore Skill Future is a similar HDIF. Need to pass the assessment. So they give a theory test and a practical test lah. I only ngam pass only, so I didn't take level 2 already because I no confident that level 1 only like just nice pass only.
Yeah, that's why need practice.
This drive is a level 2, they got say lah. They also got course, but I no confident take.
Then did they teach analog?
For the 1500. Analog. They got teach lah how to, but the what? They got teach a function like move, mathematical function like add, counter up, counter down. Analog they got teach how to the S700 using the V18, right? How to configure the PLC, then map with the ET200 SP, then put the analog card, then change the value setting of the card, like become scaling of the 20 milliamp voltage, all this. Then set up the, I slightly cannot catch up the speed very fast. They want to find it all. Then they teach the function block, call program, subroutine, FC,
DB.
Yeah. So I cannot catch because they need to declare the tag, data very fast. They teach because I'm not the engineering base. They got teach about this hexadecimal, binary, all this, right? They got tell a little bit how to understand the data that might, because I don't have a fundamental that then you also got tell a little bit cannot absorb very fast. I will try install this V18 from this got one website PLC4me.com. But I don't know after I install my laptop is totally cannot on. It become like boot corrupt error. Once I connect to the net, then after that I managed finally reinstall back the whole PC. Then only I save my laptop back.
What version you download? You install?
V18 I think. It is not the only one I believe. The website is reliable, or some might set wrong.
No, the license you put already. The license. They ask you to put the license, right?
Yeah, I did it all already. I download all these steps. 7, UTC.
Okay, the install version
17. Oh yeah, 17. Then after I install, right, you got show
error. You show me what error. So how is this?
that totally cannot start up.
Yours is Windows 10, is it?
Then after that, I try to reboot, then come to here already. Wow, big locker always. But if I disconnect internet,
They
then can run everything. Then I also can open the V17, the PA portal also can open. Your experience. Or the snap.
No, because I never use version 17.
Oh,
Mine is version
18. I worry, not sure my laptop can support or not.
18. Can?
Yeah, the
16 now.
I worry.
Because this is a 16 GB, 250 GB RAM, and 250 GB SSD.
But this is a system of 64 bit. Can support.
Yeah, of course. Mine even, I use i5 5th generation, you are using 12th generation.
8 only. Can ah? You see? 1.7 your this is 2 point something.
Yeah, but this one is I5 2.3. This one is I7 1.7. Yeah. Okay. There is 16 speed line.
Let me go back. I will again. This I worry my whole laptop.
No, what do you do? Now here to that.
So I totally uninstalled because my working laptop cannot use after I run. Then lucky I still can recover because it keep reboot here, then here, then here, then here. Wow, very scared because a lot of my working data here.
Yeah.
Never mind. No.
Before we install, restore point first. Yeah. Then when you want to install, you install in do you have the fiber interior
No. I using the Windows one.
Okay, before you install, you just off the this one.
Windows.
Yes, what?
Before install.
Before install. Then.
All this all
No, just this one.
this one.
Then.
Oh,
Yes.
real time and these two.
Yeah.
This one. All.
On. That's the yeah. Yeah. Just, then install. You left already have PLC software like RSLogix.
Yeah, that one is a 500. Right, the day after that I try, still can open lah. Not sure it affected or not the Siemens one. And I think now still left, some leftover. It's like Siemens file cannot uninstall anymore.
Yeah, of course.
I saw some
Symmetric.
yeah, don't know where already. I saw it's like still. I need to open this simulator first. How will they be HMI? Okay. Here. Startup or what? It's a startup or what? HMI. Okay. You will teach one step. Which one? RSLogix 500.
Yeah. Use both are good. This one I think 500 also. Okay. Upload first.
Upload.
Yep. No mark. So check the indicators of this PLC and your laptop IP address is 16. Check it.
Okay, already read. Check.
Okay. For this one, you can check that. The LED in the internet module. Cannot open that. You check that. Can you see?
Oh, it will always reflect here or what?
Yeah. Okay, I mean here is correct. This one is correct. Okay, the 200 is correct. But I think the laptop IP address is not. So we need to change.
Oh, I know which one is which one. Which one?
Yeah, this one. Because it is good PLC SIM.
Oh, SIM.
No, here is a 200.
Two,
So, yeah, so must 220. Yeah, okay. Plus. Okay, so cancel.
Yeah. Oh.
First you go to RSLogix Classic. Okay, check first. Click here. Okay, not this one. It's a 2164. It's a different L32E. Okay, close. Open this. Okay, yes. You click open here. Click back here. Yeah. Okay. So always in the RSLogix Classic, you need to check is it can communicate or not. Then only you can upload. Okay. Now can minimize. So now the path is make sure the path is correct one. If no, we can click who and
Okay.
then we can upload.
Looking for which one?
Yeah, select. In the desktop. Go to desktop. one folder. New folder. Okay. Yes. Put the name. Input your name.
Oh,
Open. Yeah, save. Select. Yes. Wow. Go to main program. Main routine. Yes. Okay. Save this.
save.
Yeah. Yes. Okay. So this is how we upload. Okay. Okay. You managed to get the project. You want the PLC5 to convert to PLC.
Okay. USB. You want to?
No, no, no.
Oh.
In your laptop you have.
Huh?
In your laptop you have the file. You can, I think you can use the HDMI, sir.
HMI.
HDMI. You can connect to your laptop also.
No, you need to open what
The file, your machine file.
but my this is a Logic 500 one.
Yeah. Want to see what the device they use. Can open. But yours can open the RS500?
100, yes.
Can ah?
Yeah.
Here you have.
Yeah, I already done. Yeah, I already done the activate.
Okay.
You mean open the last one, my old project file?
Yeah.
Which one? The
Anything.
huh?
Anything. No, what I mean is, your machine file. Do you have the files? No.
Last time?
Yeah.
Yeah. Yeah.
But this is the PLC file, right?
Yeah, yeah.
This one, the 500 one don't have. Is it this one, right?
Yeah. 500.
Uh,
The old one, the training one.
no, not training. Your system.
System one. This is the 500.
Okay, you open this one. I want to see the control link. Yeah.
Please.
Can we just hit the.
How to arrange the
Yeah, can you go to window? Arrange. Yeah. Go to controller property. Five zero two. Okay. Plus. But are you configuration? Okay. So. What they have? Interface module. Okay. Then the control next scanner. Oh, they use two, is it?
Yeah, two backplate.
Two, right?
Yeah.
Two backplate. Okay. Go up. Go to the, yeah. You double click this interface module. Okay, okay. This one is the one they use the scan analyzer with DF1 means analyzer is the different system, right? So they use the RS232 port. DF1 is a RS232 port. Okay. Go down. Okay, good. Okay, go down. Then next. Zero to here. Zero to 7. 31. Just multiply and go all the way down. This one is the message. Consolidation out to the field processor. Address and send. Okay, go down. And separate.
This is my machine, they interface send out the data. Then the main thing is a PLC file collect the signal from this here.
The configuration is in PLC file.
Yeah, this is a internal. Okay, I understand this is the internal of my machine. So they run the machine inside, they got own process and evaluate, analyze all this data, then they send out. The main triggering the ladder like input output, activate the light, interlock, all this is by PLC file, not here.
This one what they do?
this is the machine. So they got sampling, analysis of the air, water. So they will do the analyze so interface with the computer. So they will send out the signal if the threshold. So they will send the signal to the PLC file to trigger the things. So inside here, you don't have any ladder or program to interface with the SCADA and PLC. I mean, not the PLC. It's for the control on site.
Logic lah, logic
Yeah.
side. Logic side is the PLC file.
Yes.
PLC file and others all is now is a control logic, right?
Yeah. Yeah. This is the internal. So we don't
this
see the
is-
things here.
Yeah. So what's inside here?
This 5,000 software can open the PLC file also can.
Can convert. But in the laptop, I need to install the 500. In the same laptop, I must have a 500 and also 500.
This one doesn't have.
No, I only install 5,000.
Oh.
But last time I installed 5,000 and 500 together was fine. But now I know I was error. In Windows
That one
10.
also don't have.
That one is 500 only.
Oh, okay, separate.
I make it separate.
Okay. Maybe only can see something at the PLC file program. Here don't have
But you don't have PLC 5 software, right?
software.
Here I can install because you need to install it in those other videos because the latest version I don't have. Never mind. Connect it. Go to file, new project. Okay, it's L73 here. Okay, you can put day 5, lesson 1. Okay, then it's a time slot. Okay, it's your folder paper. Then at the back plane, right click, at the back plane, new module. Yes. Register. Second module is I think is ENBT. Yeah, search here. ENBT, yeah. ENB. Yes. Okay. Can put Ethernet. Okay. Begin 192. No, our own IP address. 200. Okay. Then this input is I think is IB32. IB32. Yep.
Revision 3, correct.
3 okay. Because you are using compatible, right? So it's okay. Put DC input. Okay. Then another one is right click. New module. So output is the OB30. This one. Okay. Save first. do a simple one first. Okay. Because now I want to show how to do control net programming lah. Okay, but I think for that to install different software and minimize this. Research RS and it is you click here, you go down for Rockwell, go down slowly Rockwell.
Yeah.
Yeah. Okay, go down. Okay. Need to install if you want to do the control net. You know, you say because they're using control net from the drive, so you need to install RS network software. Different software. Inside there only we can do, you know, how I can do some comparison. In the third quarter they show you how to do the S5005. Then you can just add ED200.
Yes.
Like this, right? Drag and drop, right? Yes. So that type of configuration, if you want to do for control net, because in the PLC, because you see you have a PLC, then you need to add a control net, right? So we need to do in RS network. Okay. Let me see. I have this. Your laptop have RS network or not? RS network. In your laptop you have RS networks? factory also cannot download. They ask for the license.
Oh, okay.
Because that is the software you need for do the configuration. The control net configuration. Because your system is using control net and also device net, right?
Yes.
You use it to use
I tried to open my old, sorry, my previous lesson. So the ladder is so low quality is because the software problem or what?
you connect to
This cannot edit, right?
Edit.
Eh? It's not can. Eh? Just not cannot.
But this one is nothing. This is nothing.
But just now I tried insert round or anything, cannot. Can. Okay.
Yeah, we go to here. Go to the
Which one?
no, just go to the software. We do the configuration for analog.
Analog.
Yeah. Okay, so what we do, go to right new module. We do the configuration now because we don't have the analog input there.
Okay.
Analog input IF in it's another model S732. Here you uncheck all this. You click here. Click on the analog. So they have so many analog type, right? Okay. Put down. We choose the this one. IF 8 also can. Click. It just put AI 1. Okay. Double click here. Do properties here. Okay, wait down. Slot 4. Go to connection. We inhibit the module. We inhibit because this module is actually is not there. Correct? In the actual hardware. Okay. So go to the configuration. So actually right here you can choose the range, which range you want. Okay. Then 0 to 20 million.
High signal.
Yes. So it's a high engineering. Okay. Actually here itself you can do the scaling.
So for example, usually
Million is 20, right?
So low, where got negative this card?
No, because just now it's
0 to 10.
0. No, just now it's 0 to 10, right?
Oh, this one
Just now
right?
is this one. Yes,
Mm.
that's why.
So this is supposed to put 0 lah.
0 or 4 also can. Depend on
But
the
AB
model.
got cut is like 0 to 20 million. This model have.
Yeah, 0 to 20.
Have.
Yeah. Because they have 0 to 20 or 4 to 20. Okay.
Okay.
Let's say we are using 0 to 20. Okay, never mind. Use 0. Okay. Then
Okay.
good.
Okay. Because sometimes when my scaling is like, okay, 20 maybe is equal to 40. So 4 is equal to 0. Yeah, it's something that is similar to my reader, to my sensor.
Yeah. So it depends. Then
So this is, sorry, here is a put low signal is supposed to be same with the cut 0 or?
okay, it depends.
or
It depends. Okay, you know why? Because let's say but the thing is availability of course like you can change this to according to milliamp or voltage current. Okay, but this one don't have the 4 to 20 milliamp.
Yeah.
Right. Okay, so this one 0 to 20. Okay, no problem. Because so, but here I need to choose 4. Okay, 4. So if I because when the device is 0, I will get 4.
yeah.
So the low engineering I want is 0.
Yeah.
So not I can't use 0 here. If 0 here, then because it is
I need to put negative here can or not?
okay. Because what we are doing here, we are doing this one, this conversion. So your now you put 4 to 20. So this is the engineering unit, right?
Yeah.
This is what they call actually AI lah. So you do scale for 0 to 40. That's it. But your device is 0 to, I mean your PLC is 0 to 20. Your instrument is 4 to 20. So I put X. If I put so what they put, of course your A, this one is 0 to 20, but what you put is 4, right? So your graph will be like this.
Yes.
Okay? Because if I put 0, so means the reading will be from here.
Then negative, can I put low engineering here?
Yeah, okay.
I don't know how to calculate.
Oh, if you want to, the low signal you want to put 0, is it?
Yeah.
Okay.
So, zero here mean, wow, this mathematics need good.
What's that?
Mathematics need to be good.
Yeah, right. No, very simple. So this is y equal to m match plus c. So we need to find the c first. And need to find the m. M is what? Because we don't know what is this, right?
Yeah,
We don't know. So 40 divided 16. Okay, 40 divided 16, how much?
40 divided 16. 2.5.
2.5, is it?
Yeah.
Okay. 40 divided 16, 2.5. Okay, so to find out this place here is C equal to y minimum minus mx minimum. So y minimum is 0. Okay. So 2.5 multiply 4. Multiply 4. How much?
2.5 multiplied 4. 10.
10, is it?
Yeah.
So this place here is 10.
Negative 10.
Negative 10 of course. Because negative 10, right?
Yeah. I forget. Last time I learned HMI, got learn idea, but
Yeah.
30 years already, I forget.
Yeah.
So, it's negative 10. So what will
No,
happen?
low in yeah.
Correct.
Correct. So what happened when you receive 4, you will get 0.
Yeah. So when
Because
I
it's like this. Okay. Y equal to m is what? 2.5. Then plus negative 10, right? Okay. So x is the one. This one lah. So you put 4. So this one multiply this 10 minus this
0.
0. So your 4 is this is the milliamp lah.
faster because after 30 years already, I already returned to the.
Because this one, okay, the thing is still not calculation done also. But the thing we understand this is okay. Then we can put it this way. So what happens if yours become, of course lah, because if it is below 4 means it's straight away, because your instrument is 4, right? If the cable broke or something, it straight away go to 0. So normally you won't get this number. Either you will get these numbers or straight away 10.
So the HMI collect signal from here also.
Okay, so what happened? So we channel 0, right? We put channel 0, okay, clear, okay?
This is what, sorry? RTS.
RTS is the what? Is the scanning of the block. I mean the device. And this one is the they call filter, right? Okay. This one is the noise. We can reduce the noise.
So put higher better or
Put higher means it's the graph will be like this lah. The value, right? Okay, it will be like this lah. So of course it won't, because it will always be +1 minus.
Yes.
Right? So this is the 1000 hertz. If you choose 60 hertz, because hertz also got calculation.
Right.
It will convert to timing. Oh, sorry. 60 hertz is the one. Maybe like this. Value. This one will be this. And we will have a high fluctuation. You know why? Because in hertz, we want to. Hertz means how frequent it read the data. Okay. So this one, if I want to convert hertz to second, so this value divide 1 lah. So if 60 divide 1, I will get 0.016 second. Means it's 16 millisecond. 16 millisecond lah. So it will take 16 millisecond. Every 16 millisecond, scan the value, update. Scan the value, update. Okay. So if 1000 divided by is 0.001 second. So convert 16 millisecond. So convert 1 millisecond. So every 1 millisecond is scan. So the fluctuation will be high here. So when you choose, if there's a small changes also I want to update, then I choose this. Small 0.01 different also I want to update, then I use this. Then if normal, then 60, and dependent you can change also. So the 10 hertz is somewhat slower. 10 divide 1, so you will get 0.1 100 milliseconds.
But this one I thought is depends on the decimal unit.
No.
You know what I'm saying?
Yeah, no. I mean, depend on your high engineering, right?
Yeah. So this decimal unit also we can. So this is the max. I mean, 0.1 decimal only. They can put like this. No difference. You know what I mean?
Yeah.
So just now you mentioned the small change.
I think so. Here need to add actually, because you know why? Because this is a floating point. So floating point always will show up to 7 decimal points.
Up to 7.
Yes.
So will it affect by this? Okay, my question just now.
Yeah.
You mentioned 1000 very fast one.
Yes. So it can update the, let's say that for example, okay, let's say for example, let's say 35. for example. If I'm using 1000, you can update this number. Yeah.
So
If I'm using the 60, maybe you can update this number. This is the 1000.
so if I put 60,
Hmm.
then here I put 3 decimal also no use.
Yeah. No use, but I don't think so. Here you need to put the decimal. How many decimal number you need? Here just put 40.
Then when I apply it will back to
Yes. Because here you just put the high value only.
maximum value.
Maximum value. I mean, what I mean is this number. High clearly right. Actually no need to put. So because this is already a floating number. Floating number is a real data type. Always have a 7 decimal points. Can go up to 7 decimal points. Okay, go to calibration. Yeah. So if you want to calibrate, right, then you can calibrate the range.
Manual key.
But this one is for negative 10 to.
Okay.
Okay. Okay, so this one here is okay. If you want to click alarm lah, just to click alarm lah. You suddenly need to change lah.
For example, I used to like maybe 20, so I spend low.
Low is 2 lah, for example. Or low is 4 lah. The low is 0. High is 18 lah, for example. So let's say I want from 18 or this is 20, then this one maybe you can put 21. If more than that.
Is this the engineering unit or
No,
medium?
your medium. It's something else. So all these for channel 1, channel 0, channel 1, channel 2, channel 3.
Channel supply.
Each channel, yeah.
So did move.
Yes,
Did everyone?
yes.
Oh. What kind of graph is different?
Or transfer because it's a channel 0, 1, 2, 2 to 2.
Why the channel 0?
Because why? I know why. Because you go to configuration, because channel 0 is 0 to 20.
Oh, okay.
No.
Oh, yeah.
Yes.
Zero.
0 to 20, yeah. 90 10. Others. Channel 1. Actually, the problem is this one.
So the maximum they.
Maximum not the issue because maximum is can go up to 20.
Oh.
But the channel because it can be negative but medium. Yes, because this range here is the 0 to 10. 10 volt.
That's not.
No, it's this range is here is 0 to 10 volt.
Oh.
The volt in negative 10 to positive milliamp is in only 5 volt only.
Yeah, so working within here.
Yeah, because milliamp we convert to volt. I mean, we do calculation means it's in 5 volt only.
Okay.
So once done here, okay, then here we can add that. Okay. Make it bigger. So, for example, this yours is what? Okay, the 40 to 90, 10 to 40 is what value? What you need? This one, right? The engineering value is what you need.
It's a concentration, like example,
Okay.
it's a PM.
Okay.
It's a concentration.
Yes.
Concentration.
Concentration, the first one, for example, okay, number 1. Then you click here. Okay, your analog number 4, right? So go to 4I. This is 4C. 4C is our configuration settings. Go down. This one on 4. Go down. Channel 0 data. MC is in real. Yes. Okay. Yes. So straight away is real. So you no need to do calculation like this. Some model like depend on this lah. Some model we need to do our own calculation. Means they only give you it's not the engineering value.
It's like the 32767
Something like that.
16 per day one.
Siemens is at 27608. 27. So same like that for this one. So, but this model because we can do the setting here. But some PLC they don't have this setting. We just give you the value. So we need to do the conversion and scaling everything. Okay. So analog output also same like that. We add on analog output. New model. Output EOF. OF. Okay. I just OF. Okay. Yes. I just put AO. Double click.
Right.
The AO. So go to connection. Key name it first. Yeah, okay. Go to configuration. It's also same, huh? We can do the high. So this is the value we set. Then it will convert to these numbers. We do only 1 for 1 enough. So 20 milliamp. What normally analog output?
So far we never use that.
Yeah, yours is mostly what reading the value, right?
Yeah.
Analog input controlling is normal digital output, right?
Yeah. So, AO.
No, just put AO lah. You don't confuse. Yeah. Okay. So this one will be the channel 5. Channel 5O. Yes, it's output. Yes. Then channel yes. Enter. You start.
Just now is order or
No, automatic once we enter. So in the concentration here we get the value like 0 to negative 10 to 40, negative 10 to 40. But of course, your instrument is 4 to 20, right? So you will get like 0 to 20, 0 to 40. And at the AO, we need to key in the value in the program. So when we key in 40, then the PLC will give 20 milliamps. Okay, good. Any question?
No.
Okay, we go for break. Then after the break, we come and see configuration. You see some system data. What system data I can get from here?
Okay.
I want to ask you something. Does your system got any heater?
Heater.
Any heating element?
Got lah. Some not all. Some have.
How is the heating element? Is it you're using the coil or what?
Got very old model is coil, but coil no longer used. Now is like, how should I say? It's a heater. Is like
Like a box.
it's a filament. It's like a tube.
Oh, the tube one. What is the range, the heating range? Can go up to what?
700 only.
700 Celsius.
Yeah. 700.
Because now I'm doing the project for UTM.
Mm-hmm.
Last that day they install one heater. That heater can go up to 150 only.
Oh.
But they want to heat up because their maximum range is 50 only. 50 60.
Different.
But it's not enough.
Not enough.
Because it's 2 meter chamber, they just use only 2 heater. It's big one. So the heater can heat up. The surface area of that heater only can go up to 35, 40 degree. After that, no, cannot. Because last weekend I was there testing the machine systems and
Maybe that's that one. But what I see is like
this one, this analog is different.
This is the difference.
I mean this analog you cannot configure the engineering unit. We need to do calculation. So another thing what I want to do,
Compact logic, that is this model.
compact logic and control.
This model.
Here L32.
Oh, L32 already.
Now wait. This. Connector connect here. Connect to this. This one connect to this place.
Lock already.
Okay, so we configure that, and also if you're using this one, right, actually you can transfer, you don't need the control net to transfer values from here to here. You can directly transfer. So this one you minimize. Save before that. Save. Okay, minimize. Okay. What is that PLC IP address? I write down at the side. Yeah.
3164. 3.164.
Actually, actually is two things.
Oh,
164.
Oh.
Okay, go to here. Yeah. Either click on this. I think that is the 164. Okay. So it's already configured, so no need to configure that. So what do you do? Okay, minimize this. So this is for the control logic, right? L73. Okay, minimize here. You open another 5000, yes. So this one we configure that PLC. Okay, new file new. So click here. L32. Go down. Down. L32. Go down. L32. Okay. Yes. Okay, version 20. Okay. You put here. Day 5 lesson L32. So this one don't have backplane, huh? Okay, this one they call compact bus. So we right click, new module. The first one, I think is what?
PC input.
PC input. For these models, you can see here the part number IQ60. But this one all you need to take out. Just put this in. Yeah. Then output is OB30.
Only 2 channel.
Yeah, 2 channel. 2 output.
Yeah, only 2 only.
Yeah. Okay. Now you go to this analog input. Go to configuration. So this one you can enable. Okay. One enough. Okay. Then we can change here. So which range you want. Okay. Then the filter lah same like that.
This no proportion.
Okay, here you see we don't have a range, right? So what happened? They have a different type of values you can get. Okay. Okay, but the values all can get from the manual. So let's say we have a voltage and also the current. Raw, and what is that? Raw engineering unit. So all these you can get from the manual. Okay. EIT percentage. Okay. So let's say for example 0 to 10 volts. This one I am using for 20 milliamp. So raw means we get, if this is, if the range is same lah. Here you select 0 to 10 and your device also 10. So I am talking about this range, not about your device. Okay. So if this is the range, it's negative 31208, not mistaken. 31208, 280. Let me check the manual. What's the model? IF 1769 IF 4I. 206, okay. Positive lah. So this is the value range. Okay. So if you're using form for this one, 29800 to positive 29800. This is the range. All this from manual you can get. Engineering unit very simple. You just add another 30. So this one is 0 to 10,000. So this one is 4,000 to 20,000. Okay. PID is 0 to 16384. And percentage is very simple. 0 to 100%. Add another 2 for better resolution. So what we need to do, we need to convert this. We need to do the calculation. Okay, so we try to do for one. Maybe we use the raw. Okay, raw is okay. Yeah, raw because because the value is very big. So you can get better values. Okay, is it okay? Now go to control tag. Control tag. Okay. Then go to edit tag. But now, like just for this one, you straight away put PPM concentration, right? Here you cannot put that. Here you need to put AI first, then you convert to PPM. For example, okay. Let's say you're doing for the PPM negative. What is your range? Is negative 10 to 40. Let's say that is the range for example. Okay. Okay. So you put AI channel 0, AI CH0 here. Then alias, choose local 3. Can you see it's in integer? If you refer to the other manual, the L30, L71, go to the L71.
It's real.
Real. It's a real because it straight away give you the value, right? We connect this. Inject 0 to 10 volt. Milliamps only. Also for training, testing purposes.
For Omron also do that, they know their scale complete very correct.
Yeah. The range is okay around. So last time I used process meter. The process meter after every 4th training, I need to change the battery. Sometimes I forget it. So I require this easier. No need battery, so just power up. This one is not so strong. Last time I buy, but this one is good. Last time I buy, similar thing. After 1 year, this one gets stuck. But still, this one is still okay. So this one goes to channel 0. The one you connected the guy? Is he okay?
You not yet start any
No, any news nothing.
give him some
Information lah.
information already.
Oh.
Because right now the customer side is like they have a worry, they concern. Because he said that he know how to do, but they need him to show like
Previous profile lah. His profile lah.
but his profile is more on eligibility PLC. Yes, they have experience.
Oh.
Like maybe is a minimum for the PLC file. They say can, but did not see anything
In the
profile.
profile lah for
Yeah.
PLC.
Yeah.
So the day is the day he called also.
How you call you?
Then he say, then I was talking to him lah. Because he opened a previous company. Then his previous company he got automation.
Yeah. This SUS automation.
But is how old? Is it
It's a SUS automation.
Ah.
I think it's 1 year only.
1 year with new company. His previous company, I think 4 years back he opened. That time I think after he come for training, the next year he opened another company.
Yeah, but that day
That company he said he already he closed because of bankrupt or something.
But he will show interest he want to do. But the problem is the customer side is a live system.
Yeah.
So they worry like whether you will like mess up the whole system of procurement.
Yeah.
So they worry.
Because of course not that, because it's not like only one system. It's like
Yeah.
already so many systems, right?
And it's an old one. So
Yeah, so need someone who can handle PLC part and also this both.
yes, correct. Then they worry if they pull in the new contractor. After that, if he mess up, then the old contractor, if they know already, then they don't want to support anymore.
Yeah, of course.
So they need to handle very careful. Still got chance, but I think now they are talking,
Oh.
but I don't know that person whether can convince them or give them a confidence whether.
Yeah, of course. Because if it's the same thing, like if I want to do some project, it's the same thing. I need to tell them my profile, everything.
Later maybe I can talk with you more.
Mm.
Hey, later you got break lunch, maybe we need talk more. We go lunch together.
Okay.
Okay, so we continue this.
Yes. Okay. I power on already. Right?
Yeah.
Okay. Now, you save.
Say.
Save. Okay. You choose the part who active. Click here. Can also. But this ours is 164, right?
Yeah.
Okay. Choose download.
Okay, download.
Yeah.
Okay,
Because
so now we put inside.
yes, I'm going to put this. Can cancel it.
No, we need to view.
Close. Never mind. Close. We click this one. Yeah. So maybe the cable loose or something.
Oh, which one?
Yeah. Always check on what here. Okay. Answer. Go to your RSLogix classic. Yeah. So you just
This one?
just close. I mean, you do not run this one. Close the yes. Yes, close. Then open again. Yes. No, okay, now open. Just now I closed, right? Okay, wait. Okay, now download. Processor. Processor. Yes. Yes. Okay. Now.
Not so stable.
No, just now I off, right? So the communication lost.
Override.
Yes, download. Okay. Now done. Okay, now go to monitor deck. Can you see? Right?
767.
Okay, you open. Oh. I go to edit. Is it correct? Check.
7,600, I thought it's correct.
No, because the maximum is 31206.
Yeah, I remember this not for this model lah, is it?
No, 32767 is 1 bit, the 16-bit value.
Maybe if you got a chance later you want recurse
Can.
revision for me again. No maximum. Anyway,
Voltage. I think our range
need to change the current, is it?
No, you choose fault value or what?
Yeah.
Oh. The fault value I need to choose milliamp. No, why? That's why. Ah, 020. Okay.
You off. Can survive this one.
And this one I need to look filter. There's this one right. This one and the 0 need to look. It's they call input return. So then only you can read what milliamps. So for voltage, is the plus minus enough for voltage. If milliamp, the 0 volt must connect to the input return. No, that one don't have analog. That's why I'm using this one to teach you.
This one is 503. It's the same model that.
No, yeah, but yours is 503, 302, right? We call 302 the model. This one is 300 only. Oh, because you maximum is 2,800, right? Of course, mine will get something that. But
Why the negative is zero is
zero is the 4 million. 4 million. Minus 2,900 means this one is supposed to be correct lah.
This one.
Is supposed to be the range. It's going to negative 42,767. what we do?
This unit is correct or not, the million of
Yeah, that's maybe it's not.
need calibrated.
No, I know that one it won't be accurate. Can measure.
Any setting? Fuse blow already. Need to change. Great. Slightly. Then how come not aligned with the sort away.
We change to configure the configuration. We change to engineering unit. Yes, apply. Yes. Okay. 4 million.
4 million.
You check 20,000 and check 0 also. Check the minimum.
Just roll the die.
Oh, okay. Go to 0, what is it? 0, right?
This is correct.
Okay. Because it's a 16 bit.
Right.
So just now is correct, negative 32,000 is correct.
So it's correct.
Right. Yeah. shows that if you're using the both negative and positive is 16 bit, so it can go up to 32,000.
No?
If only positive value, now don't have.
The maximum here only.
Now this one. No, not maximum, minimum.
Yeah, but
Zero. No, just now maximum is correct. What is now? Only the 0 volt, 0 BEM you get negative 32,000.
yeah. So the maximum is 29,000.
Maximum is correct.
So it's not the same number.
No. So I'm checking in the manual.
You are correct. 4 to 20 million is when 4 million is see, it's a negative word because
you choose 4 to 20.
if I put 0 to 20, yeah, 0 is your table is correct lah. 4 to 20 is
Because
negative.
because I put
4 to 20.
Yeah.
Yeah, if I change to here 020. Yeah, so this is a 020 lah. This is a 020. Your table is a 4 to 20, is correct?
420, yes.
Yeah, that is correct.
Okay.
Correct.
So what we do, we need to do okay. Now we plot the curve. This is our AI want to set to ppm, for example. So how much negative maximum is 40, right? Minimum is negative 10 or 0.
0. Alright.
And that's 0 lah, but just now we put because of the. So now you change to 4 to 20. You use this number.
So just now I agree to discussion is what actually they do not have a 0 negative ppm.
Yes.
But what they do is after the 0, right, when the million drop less than 4, they consider like maintenance fault, sensor fault.
Yes.
So like they put like 3 million is equal to fault. Like 3 million equal to maintenance. Then less than 3 million, like below that 3, 2 or 0, they consider fault.
Fault, yes.
Yeah, so I don't know lah. So
Yeah, I know that's the reason. Yeah. So we use 0 to
20.
20. Okay. I mean your configuration 0 to 20 lah.
Yeah.
So is negative 32,767 to 298 800 lah, for example. So this is the range, right? So this is where we need to use the y equal to max plus c. Okay? So we do this one will be a long calculation now. So what we do, we go to main.
Main?
In the main program we do like a small calculation. Okay.
Oh.
Okay. No, so I do a long calculation, later we make it smaller. So first we need to find out this one. M is this one, right? So y max minus y minimum what we do, we go to control tab, go to control tab, then you go offline first, go to edit tab, and so you can close. Okay, AI already have. Then this one is the Y is the PPM lah, so just put concentration PPM. Okay, enter. Enter. Okay. So I want in real. Yeah. Just type here. Okay. Then so now we do this way. We put Y max, Y minimum, X max, X minimum. One by one. Y minimum. All these real. Okay. Save. Go to main routine. So you need to do the this one subtract, all this, right? Okay, but this one you have the compute CPT. CPT SLC500 also got but this model cannot because this model is the lowest one. Your model not got in your program also. Okay, first we find the M. Okay, just put M here. M. The destination is M here. Okay. Then the expression. We erase this one. You put open bracket Y max minus Y minimum, close bracket, divide X max minus yes. Okay. That's all. Thank you. Okay. I think X min is wrong. Because small letter, capital letter is not the issue. Yes. Okay. Next, we find this one. So another CPT. You add one line first. Yeah, CPT.
The destination is the C.
C. No, you can put it M multiply X min. I mean, you can put in the bracket. Open the bracket. I mean, open, yeah. After the negative minus, open bracket. M, the inside bracket you take out. M multiply. Yes. Okay, that's all. X min. Then the last one is this one. Y is your, no, not Y, you don't have Y, it's your concentration, right? The concentration PPM. And you put open bracket, M multiply, your X is your AI channel 0, right? Okay, if you're not this one, you can open here. I mean, if you forget the name, right, go up, AI channel 0, all the way up. You see, your M is actually real, right?
Mm-hmm.
But your AI is integer. Okay. M.
Okay.
Okay, close bracket. Plus C. Okay. This one, same. Okay, actually, error value is okay because integer and real can calculate, but Siemens cannot. If real want to calculate integer, the integer must convert first to real first. Okay. Now you can download this. Okay, then because why? Because the y max all don't have value. So y max is what value? What number?
So we key in here.
Yes. Okay. X max is 29800.
Min is negative.
Yes.
Because I choose
Okay. So your concentration is 5 now. Yes. The concentration is 0. 0.0 lah concentration. You put to 10 milliamp, so you must get 20. Must get 20. Hmm.
You say 10 million equal to
20. Right. But okay, the thing is, yes, because ours at this big. Now what happened is 4 million how much you want?
0, right?
0. Okay. In that case, what we have to do is we have to draw like this. So here is the 4 million, right? Let's say that this line. Okay. This is 20 million, right? 4 million, 0 million. Okay. Now, 4 million, how much you get? Isn't it? Okay. So, 20, 250. Okay. So, your range must be this one. The minimum, maximum. Then only I will get this. Now you change to the X minimum, to this number.
That's minimum
Negative 20, 250. Enter.
Okay. 0. But it will fluctuate. If I follow your table, sorry. If I follow your table, it's negative.
No, because you choose there is 0 to 20. But this one is the setting for 20 seconds.
Why it fluctuate?
No, because go big, because the range can go up to negative 51 also. So you put 51. So you go to below that. I mean, go below that. You get negative lah. Go to below 0, so you get around here.
Is it normal when you reflect like 07, 07, is it like it?
0 go to 7.
Then you see, sometimes 7 point something. What does it mean?
Why?
It's similar to this M value. M is the one.
M is the strength.
When the SCADA receive a signal also like.
It's interesting, right? Actually, C is the think something okay. M multiplied X B. But your C is what? 16. That's why I think something wrong. Go to your calculation. So C is supposed to get negative. C, what is the Y minimum minus M multiplied X minimum, right? Your M okay. X max minus X minimum.
Because my
No, because X minimum. Okay. Now, wait. Okay, I know why. Because I want to use this, right? I want to do this today. I want to know what is this number. Okay? So, if I put this one, what number I get? C, 16, right? Yeah, 16. Of course, it is. Because the graph will be like this, right? Graph itself is more. So Yes.
And then my
So now you put here 2250, right? So you get like this. So this is the 16, right? That's why the offset is 16.
okay.
So when you get this, when you get the AI value 0, you will get 16.
The AI value 0, that's 16. So
Yeah.
when my AI value is 4 million is equal to 20.
So
What I see? What?
no.
No, it's supposed like that.
Must be.
Here is 40, so 0 ppm should be here.
Yes, yes, yes.
So your 2025 also should be here, right?
Okay.
Because this is the 4 million one, also is 2025. So it's a 0 ppm. So your line, but of course your line is correct.
Okay, good. So so here let's say the 22,000. 22,769. So you get something like here. So 2025.
So this is this one. Just how to calculate this one. This is negative.
Okay, that one negative then. So 0 to 40, x max is this one, minus x minus 2, 0 to but negative lah.
Yeah. How to get this? So P Y mean that.
Why I mean, yeah. Okay, now this.
Now my mean is not 0 ppm. It's logically it's not correct because ppm should don't have a minus.
Yeah,
Okay.
of course.
Just okay, because what the programmer what they did actually they're using yes correct is 0 to 20 million cut. Okay, he's also using as a ppm.
Yes, I know what they do. But in the HMI it won't show negative.
Yeah.
You know why?
Then they put to other function already.
Yes, they use move function.
Move.
Yes, so what they do, they will compare. They will compare if less than equal, right? So if the AI value lah, okay, if the AI value is less than negative 250 lah. So negative 250, what they do? They use move 250 into the AI calculation. Let's say AI X lah, different lah. This is the original AI.
Okay.
So they do like this. If greater lah, right? If let's say greater or equal. Greater lah, greater. So if the AI is greater than 20250, we use move AI into AIX. What they do is, so this AIX they use for the calculation. This is the original AI. So what they do, if less than this one, so the AIX will be value will fix at 250. It won't go negative. It won't go below this. If the value is this value more than this, then whatever value here can move to here. The analog value move there. Okay, we can try also. Maybe if we do, we can get the correct value.
Okay.
Okay, so what we do, we go to our main. Okay, now you go below. Now it's 4 million, right? Okay, no, go to 2 million. How much you get? So I get negative 4, right? Okay. pressure, we do something. So you go back. We do something else. Before that, okay, go to control tag, edit tag, offline first. Okay, so you put AI, this one AIX. Okay, is integers. Okay. Okay. Go to main. So now here you use the AIX. X. Close bracket. Okay. Now here we do this one. Compare. Less than equal. No need less than equal, less than enough. Less than right. So source A is the AI channel 0. Okay. If this value is below than this, negative. Then put move function. Move, yeah, okay. And move also. Yes, okay. So move what? Negative 250 with 2050, okay, into AIX. Okay. Yes. So what happens? If this value is below than this, so the AIX value always will be this only. So if below than this, it won't calculate. Because this is the one I'm using for calculation. Okay, now next one, add another one. So if above what happens? If greater or equal, use the GEQ. No, compare. GEQ. Okay. Same. If the AI greater or so negative 20250, okay, then I move the AI channel 0 to the AIX.
Move that.
Move that. I mean move the analog value lah. Okay. Save target. Again, we put all the values.
Oh, every time need to put that.
But later we can put it, I mean, direct also. 40, okay. X max is 29800. Okay, X minimum is like 20250.
Huh?
Negative 20250.
X minimum. X I thought is the AI cut scaling.
AI cut. Okay, now we try and see.
Why mean remain 0?
That's right. Wait. Because this one go to negative.
No, I put 0 or I put 4.
I put to 0.
0. This is 0.
0, yes. Because if I put that way, it means the graph must be this one. Like this. But the thing is, you know why? Because why I cannot follow this. I need to follow this because my PLC is 0 to 20.
Yes.
But the device I want to count is 4 to 20. So this range, right, is this range is actually for the 4 to 20.
Yeah.
So we have to calculate regarding according to this. So 4 million, how much? 20 to 50, right? So we follow that. Okay, I get 0. Can you see? Supposed to get negative value, right? You go to above. Starting from 4 million, you can get. You know why? You go to, yeah, it won't fluctuate. You go why? You know what? Go to me. So you see, because if this value less than this number move to here.
If the channel data is less than this, then you always move to
Always the minimum. Always go to the minimum value. If above,
and go back.
yes. If above, it will follow the analog value. Yes. So because now this one won't work. Now this one will be energized. In Siemens TIA, they teach you the compact.
Got lah, very fast. They got teach move.
Move lah.
They got teach move, add. I think these two only move and add. Move. The rest
Timer, counter,
have lah, timer, counter,
normal lah. I mean, you can see here, set, reset, pulse, counter, move. In the HMI, they teach you button, lamp.
Yeah, very simple one. But the last practical assessment test I failed, he got show how I fail. He got one question very difficult. I cannot write the letter. One push button. When you push pump A, same button, only one button. When you push button A, when you push first time, pump A, run. Push again, pump A, stop. Then you push again, pump B will on. Push again, pump B stop. Same button. I don't know how to configure same button can. You know what I mean?
I know.
Got pump A and B.
Can use the counter.
Yeah, my other cosmate will tell lah. Can use the counter when counter up, so you.
One on. Counter 2, value 2 off. Then value 3 on B.
B.
Value 4 off B.
Yeah, but because the training is, quite.
Yeah, 5
quite
days is compact, you know.
very compact, so I cannot remember how they write the ladder of the counter. So try fail because they given like 2 hours need to finish.
Oh, they do that.
It's like a test, not like our this training like
Yeah.
because they need to claim the UTI fund, so they need to
Do the testing.
do the testing. Quite
But actually, if you ask me, PLC can do testing.
quite stringent. But maybe I would say the whole class got 8 students and
8 students.
8 right? 8 packs, total 8 packs, maximum 8 packs only. Yeah. So I guess got 3, include me, fail lah. Not say fail lah, we all pass. But the 3 of us is like ngam pass only. So another few engineer, I think they have some engineer background and they got quite familiar also with the PLC already.
Maybe they are familiar with the PLC.
We spend 2-3 hours to figure out. Then I see them 30 minutes already finished. Then submit, they go back already. But before they go back, actually the trainer got check their result lah. Okay, they see, okay, correct, or you get correct, do a show everything correct. So yeah, counter. I forget already how to do a counter. Even your this AB I also forget already.
Yeah, of course. Need to use. I mean, if the same day I teach, then I ask you to do, can do.
Yeah.
But today I teach, after 2 days I ask you to do,
forget
then
already.
cannot.
Maybe simple one, open, close. Normally close, normally open, coil, time I still can remember a bit. Set. Or they also will teach set to reset. Set, reset. Yeah. Fast. Yeah. Want to go for lunch? It's good training. I haven't received their certificate because my company also the purpose is we want to get the Siemens certificate.
Okay. So
The certificate will
did
they will have but not yet processed. I don't know why I need to change
Oh,
that.
yeah.
Because they want to get my company want to get
So is
brands.
the company's direct Siemens or they are it's under Siemens?
My company? No.
I mean the training provider is
It's trained by the Siemens. We go to the Siemens.
Oh.
It's trained by the Siemens. That's why we want to go there. Yeah. Cheap lah. Because after the HDIF, we only pay around 1,000 Sing only.
Oh, after also you need to still pay.
I still need to pay. Because you need to see because we are not Singaporean.
Oh, yeah. Same lah.
Yeah. If Singaporean, I think they still need to pay, but I think it's only like pay maybe 200-300 Sing dollar. Very
The
cheap.
balance they will claim from the government.
Yeah, claim from the government. The balance will be offset by the government. Because we there, we are not Singaporean, so maximum only like claim up to certain percentage of it, not full claim.
Actually, is a government fund or
Government fund.
no?
It is
Because
what?
HRDF is not government fund anymore.
No,
No, HRDF is actually after
it's
government.
by government pay ma.
But it's actually is from your pay. From your pay.
Oh, yeah, I get what you mean. Yeah. When you deduct this KWSP, your money you
Yeah,
put all
not
inside.
KWSP. Okay, it's like this. Each company
You need to pay HDI fund.
HRDF fund of your salary, 1% from your salary, but not from your salary. Like the company will pay the HRDF. Later the company can claim.
Yes.
Mm.
Same lah. Correct.
Mm.
It's same. Yeah, Singapore also we pay the SDL.
Ah.
So skill development
For
levy. So for
Yeah,
this
same.
skill future.
Yes.
That time you took the pen, right?
Yeah?
The pen. Because I saw there's only.
Yeah.
Oh, okay. The first day I didn't give you the pen.
I think yes, but I don't know
You
where
left
place
it over
already.
here. Yeah. No, it's for you, it's complimentary. Okay. Okay.
Oh,
Okay. Oh, you change, huh?
no, no.
Oh, the same battery.
You do that question of
Oh, maybe the button already covered already. But I don't know the calibration perfect or not.
just keep looking at your
No, go near there and try and see. No, it's the calibration. 23. Perfect. No, not really perfect, lah, but just nice not to read.
You just want to test, to test the heater because heater can go up to 140 only.
Oh, okay.
So this is the heater. The heat can distribute until here.
That one part of the heater until there only.
No, it match. This is the heater. This is the heat.
Heater distribution. They bought the wrong one,
Not wrong one. Because you cannot blame Shafi also. Shafi is the one buy that. Because they say the heater can go up to 60 only.
I think maybe the calibration went wrong or something.
Not the calibration. You know what I mean? They want the chamber to 60 degrees.
Okay.
So this is the spec they give to Shafi. Shafi check. Okay, this heater. You can go maximum 100 plus only. It is just nice. So they ask to buy two. You just buy two and fix it. Yes. It's not good. Design is also because that day the small one I asked the direction to open, then you open that I open the plate and see. And we on for like around 10 minutes, it's already go to 40 degrees. If I open and see at the side, they have a metal. So all the metal got same temperature. So
The heater they fix the metal board.
not metal or something, but it can distribute to all the place. This one also need to design something that means outer temperature cannot affect the inner temperature. Now the outer temperature is affected.
Now the government will additional box.
Yeah.
Make sure you explain to her. Because today around 5:50 like that, only need to pick up also.
Yeah, right.
Because you already got all his bus.
Mm.
So okay.
Just know where we stop.
Okay. So just now we key in like this, right? The value, right? Okay. Go online. Okay, like this, right? So just now we key in here, correct? Because when we download something, we go to 0, correct? Just now the value go back to 0, right? This minimum maximum values. Okay. Because why? Because we are using a tag. Okay. So every time we download, the value becomes 0. So once we confirm with the value, what we can do is go to main routine, we go offline. Okay. We go all the way up. So this minimum maximum, right? We can straight away key in the value, only the Y max. Okay, you double click, we change. So the Y max is what? 40. 40. Okay, the Y minimum minus, just minus 0 lah. Even though it's just 40 only, right? So later when you refer, you can understand. So X max is 29,800. Okay. This one you put in a bracket because negative. A negative 20250. 250. Another bracket. Alright. Then here also the Y mean X mean. The Y mean is 0. The X mean in bracket. M is correct. M is correct.
M is what?
M is correct. M is this. Is from this calculation. So just put M. The X mean only in bracket.
X mean is
Negative 250.
0.250.
Yeah. Close it. Okay. Okay. So it's not okay. Because so no need to put like a tagging Y max, Y minimum, and straight away that this is okay. Okay. See. Okay. Download. So this one. So now we are not using this Y max, Y minimum, X max, X minimum. Now we're using the direct numbers. This one no need calculation. But I might not, we can just leave it out. Okay. Okay. Now we go back to A. So this is one type of calculation. Okay, there's another type of calculation. That is, we don't need to do the calculation. We just need to key in the minimum maximum value if it calculate for us. Okay, there's a block. So go offline. Go to main program, right click. No, open. Okay, right click. New routine. Okay, just put scaling. Okay, and don't use ladder. Click here, use function block ladder. Yes. Okay, okay. Now go to main routine. Go all the way down. Yes. Okay. Make sure, no, you take break, make sure this one becomes blue. Yes. Okay. You double click here. JSR. This is the similar like the similar call block. JSR. Enter. And here you need to add this block. Scaling. Yes. Enter. Okay. Because This one is the OB1 actually.
Mm.
This one is the FC.
Okay.
The add-on right, this is the FB.
Mm.
Okay. Now you open the scaling. Inside scaling, click here. Go to process. Okay, they have this function. Yes. Okay, you bring to center. This is a scaling block. Scaling block, normally some PLC they have in ladder, but in LMRD they have in function block diagram. Because PLC not only ladder, right? They have ladder, function block, they have a structure text, then they have a sequential function chart, and Siemens they have additional called instruction list. Now, click here, open this. You make it bigger. Okay, so can you see? So input is this one, output is your output value lah. And in raw max, can you see? Raw max is your X value. EU means your output. Okay, just enable this, all the four. Okay. Okay. That's right. Now we need to add all the values. Okay. Now you take this one. You bring to this side. Okay. Now from here to here you want. Yes. Yes. Same like that. You need to add for this one. The Siemens are how they teach. Is it they use like this yours or they teach? They use their laptop to show.
Everyone got own laptop.
Okay. In the main one?
Main one, they ask us to do lah. Then they also got show lah. Sometimes show, sometimes they also got cost material.
Oh.
They also got cost material. They are more on talking about the this what?
Siemens.
They also got like explain the every function, where it come, how it come.
Oh. All that. Theirs is more to theory.
Yeah, theory.
Theory and little bit. Because last time I attended one of, not Siemens actually, it's a back off. Same
Of
for
German one.
German also. Okay, another one more. They more to their, they tell how good their product, all that.
They also got hands-on practical lah. Just they also got teach, but mostly they will explain function lah.
Oh, how? Okay, so now here you key. Double click. Okay, here you choose your. We use the same analog. Okay.
Yeah.
Now the AI channel 0. Yes. Okay. Then this one all. Okay. Raw max is what? 29800. You just key. 29800. Okay.
Just now we already delete the Weintek. If we can put X max here, the wording cannot.
Can also, but you need to manually key in again. This is like a constant, directly fixed number.
Okay. This means
In row, okay, negative 20250. Okay. Then this one is can. Don't worry about it.
so this is the max.
40. Then this is 0. Okay. The output, we add a new output lah. We can use the same output. Just put concentration 2. Okay. Right click new. Because it's a new tag. So I show you two type lah. This is okay.
But this one, this function block. How are we going to organize it? So, like everyone, 1, 2, 3, 4.
Not necessarily. It's depend on how you arrange it.
After we,
No, now it's online. You cannot do. So can you see here I get the. Okay. But it's a 0 point something lah. No, this one will get negative value because we didn't do this function here. So never mind. So you go to maximum. I mean, you go more than 4 ppm. Yes, again, right? Okay, leave it at some value 13, 14. Okay, 14.9, right? Go and check in the main routine. You go up. What is the ppm value? Go up. Why this one is 78? Something wrong in our calculation.
this is
Oh, you didn't put negative.
in bracket, right?
In bracket, but the value is negative. Right? Never. Good.
I thought bracket is negative already.
No. Okay, no need of that. Okay, actually we can do like this. Okay, now what you do, you double click here. Okay, when you double click, you create like this. Okay, now you put negative. Okay, enter. Okay, LMWD have one function called, okay, you click here. So when you do online edit, right, it will create like this too. The day I teach, right, I don't remember.
Yeah,
I mean, I teach
but
you.
cannot remember already.
Yeah, long time ago. Okay, now you see it. LMWD got this function called online edit. Okay, because like Siemens, because you do Siemens, that's why I can compare easily, very easy. Siemens, you can download hardware and program separately. Okay, but LMWD no. LMWD, when you click download here, it will download everything. So if you want to do something changes with the program, this is the way. It's called online edit. And one good thing about LMWD, okay, this is an edit I do right. Okay, click here. Accept the pending. Before I finalize, I can test first actually. So you see, this is the green now, right? Okay, means now your PLC is running this program, the older program now. You click test. Yes. So now it will run this program. Now you see 14.9. Get the correct value. So, and you can leave it like this also. Okay? You can leave it like this, it can run. For example, if another guy come and check, right? So he know you do this. So if this one is okay, everything is okay, correct, then you finalize. Yes. So when you finalize, the older program will be deleted. So now you see, you can use this way also can do, scaling also can do. But in ladder logic, you need to do manual calculation. In function block, they have a block for you. You want to arrange, can arrange. Look.
I was curious.
Just bring up. Okay, give some space for this.
Wow. So that's why also ladder logic will be better.
Yeah.
So if example I have 100 of this, how?
100.
So how they troubleshoot it if go by scroll down, scroll up?
Yes. But actually can. Okay, what you do? You bring back to
You see, if we mess up like that, right? How do I know this one go to where?
Yeah, you click here, bring to the center again. What you do? This one right, actually we can bring to near. Yes. Okay. All this you bring to near.
The line or so you put it this way? line will be still remain.
Okay, I don't know why. Can you highlight this? Okay, you highlight all this. I mean highlight. Yes. Okay, now you move to the side. No. Again highlight. Undo.
Okay. Wait.
Okay. Yeah. This one running back. Yeah. I mean like a design, right? Okay. Yeah, of course. Highlight, then you bring. Maybe the space.
Left, the most left already, right?
Yeah, most left.
Good.
You need to arrange. That's the.
Wow, very annoying, isn't it?
Yes.
Huh?
So the best way is
Got one button like auto arrange?
arrange.
No.
I will so no. Of course, it's not arrange. You like it here? No.
Not nice. So the best is from the start,
Yeah.
you already need put in the correct place.
Correct.
You no need waste of time, you will rearrange.
Yeah.
Not change.
Good. Don't go near. You go at the all this. You arrange. Go back. Go back. Yeah. Okay. Think a bit far should be okay.
Oh.
Yes.
So they follow the route. If I go in this way, I go in this way,
Yeah.
and
So you need to take a straight line, then you go bring near something.
Mm.
Yes.
this person not friendly.
Yeah. But the moment you move somewhere, because it's like move.
Like bring them.
Yes.
See?
Ah.
Mm.
Undo means then you gain. You do.
Yeah, see.
Yeah.
Uh,
Alright. So what we can do, of course, like you said, this one means,
mm.
if you have multiple then difficult, right?
Mm.
So what you can do, you can create add-on instruction. So in the add-on, you do the scaling block, the scaling function. Then you can add. Maybe we can try one. Because normally that's what they do. Already exists.
Oh.
Or you copy paste, right?
Yeah.
Cannot. Because copy paste, it will be taking all this data.
Oh.
Ah.
Okay, they do the same. Okay. Okay.
You will right click add-on, new add-on. You put scale analog. Okay. No, change type. I don't want function block. Can use function block also. Never mind, we use ladder. Okay. Use ladder.
Hmm?
Ladder, use ladder. Okay. Alright. Okay, go to parameter. Okay, here we need to key in all the data we want to use. Okay. So you put AI. Just normal AI. Okay. Input integer. I. Okay. Then here is the Y max. Okay, real. own block. Okay, then sorry, this one we put winding. Winding. Okay, X max. Okay, X min. Then this one is the out. Okay, the out we change to output here. Output parameter real, all this real. It's two also real. Okay, then you must click on this required. All that required. Here. Yes. Then go to local. Because we need to calculate the C and M, right? We just put one is M, one is C. M, okay. Here, one is C. Here, okay. Alright. Here, okay. So here got logic, right? So this is where you need to do the logic. Okay, click here, double click. So this is where this is where we need to do the logic lah. And you go to main routine. Later we do the logic. Okay, now I show you what is the advantage. This is something like function block. Okay, go down. Add 1 9. Go to add-on. Yes, you add this. Yeah. So it will be like this. Much more easier. Then multiple time I can use. But inside the block, I need to do the program. Yes. So we try one next. Go to the logic. The same calculation I just done. Use the CPT. Put 3 CPT. 1, 2, 3. Same also can. Okay. First one we find the M. Okay, so M. But inside here, you click here. You click there. It will only show what we add in the parameter. Okay. Here it won't show our technique. So only can use what we use here. Okay, M. Yeah. Okay, correct. Then the expression same lah. This one just now. The y max minus y min x max minus x min. In bracket. Y is the output, right? So put output. Output, yeah. Okay. Then the expression is M max plus C. So in bracket M multiply MM. M multiply AI, right? No, this is correct. AI. AI. Yeah, okay. 2 AI. Close bracket. Plus C. Okay. So this is the expression. Okay. Now go back to me. So this is like a block, first block. Right? So each block I need to put a name for the block. Okay. We put scale 1. Scale 1. Okay. Right click the scale 1. New. It's like you add a timer like that. Right? Okay, same. Okay, great. Okay, done. From AI. So AI we already have, right? We use the same AI. Right? AI channel 0. Yes. So what is the Y max? 40. Y means 0. Yes. Then the output, okay, let's say it's a new one, we put concentration 3. Because output I cannot repeat. Okay, right click new. Okay. So we do 3 way. One, I straight do the calculation. Another one, I use the function block. Another one is I do calculation in the add-on, and this add-on, right, multiple time I can use. Each time, new name, new analog. You download and see this value is the same like this. Go up the value, increase the value. Same, huh? Same, right?
calculation be wrong, is it? Because now 4 million by right is a 0 one.
Yeah, is it 4 million?
Yeah. Because by right, where I go wrong? So this 10. Yeah, now 10 million, only 15.
Oh, must be 20, right?
Hmm.
Okay, go to that 20 million.
Yeah.
Now it's 29,700.
Hmm.
But we put 800.
Hmm.
Maximum value, that's why.
Hmm.
29708.
What? It's a calculation problem or what?
No, not calculation. This because we check this one only. This one is not calculated. But maybe the one what the injector. Yeah, the calculation is almost same lah because all the calculation is same.
2025. So I put
0.
is 32. I'm just curious where
Here
we
get
go
0.
wrong.
Right. Here get 0 value, right? But these two, no.
Yeah.
Because didn't do the this one.
Okay.
Because for this calculation, the first calculation we do this one. If less than 0, this will be our value.
But the problem is now I put 4 million. Here see got reading.
1.6.
Got reading. But right, it's no reading on 4 million.
0,
Just-
right? Yeah, because your maximum is not 29. So it's like this. Okay, you see, your calculation is this one, maximum. Okay. But actual is 29,700, right? 70.
Only 100 different.
Right. So it will be the same thing, right?
Yeah.
I think then the lowest number also not same lah. Lowest number is what? If 0 milliamp, what number? Sorry, 4 milliamp, what number?
4 million.
Now
Now it's not correct already for me. That's why.
it's not 2025.
No. Don't see.
20.
Oh, it's correct. 244. Slightly different neighbor.
Slightly different lah. That's why there's a difference.
But you see the real time is too big already. The gap. You know what I mean? The error.
Yeah.
3 point something like. Is it? I see it.
No, why 3 point something? Because of this calculation different already. Okay, we see why. You see, and y max is what? 40 divided 0, 250, sorry, 2980 minus 250, right?
Yeah.
This is solution, but now it's different already, right? Let's see. Now is 29,700, right? 706 20 2 such different lah. So that's why we can check. See how much. Small different only.
Yeah.
But this one, it means one value of this is equal to this. Means one number, one digit. So if, for example,
just now before we do the second part one, I think it's a correct. Or because we do the move.
no, that one is all okay. Wait, what I know. I know. Now we just take random position.
Okay.
We use these two calculations here. Random position, we just ignore the C. Just do some calculation. Okay. Let's say because it's plus C, plus C already. Let's say 20,000. And somewhere here, 20,000. I say this is the 20,000. Because if 20,000 now multiply this, what is the 20,000 multiply 0.000792. This is 15.984. If 20,000 times 0.0008 is 16. Small difference. So that's why. So now I get this negative 2250, right? 2250. You go to your calculation. Why it's supposed to be 2250? I mean, it's supposed to be 0, right? 2250. Okay. No, go to scaling. Let's see. It's 20250. So we key in this, right? Negative 20250, right? Okay. Go up. Go to main routine. You also say negative 20250. Negative 20250. But now I get 245. Why? Now below value less than this, go down. Why this one got this number? Supposed to move this number right here. Because this number is less than this. This number, right, is supposed to be this number, right? According to this, if less, this value less than this, I move this to here. But it's not moving. Why? Something wrong.
Less than what? Don't see when I less than. So when I increase, correct lah. Now the less than is when negative reduce only.
Okay,
Correct,
okay, okay.
correct. Correct lah. Yeah. So when bigger negative mean less than what? Unless use greater than.
Oh, yeah. I mean, it must be bigger than this, right? So this value becomes 0.
So my question is
Actually, this the 4 milli-amp, right?
yeah,
Okay. It's actually not 3. Okay, go back to the go up. No, go to control tab. You make it bigger, this one. It's not 3. You know, it's not 2 actually. The value is, because they put what then?
What do you call this one?
I mean the exponent, right? So 3.99 times 10 to the power of negative 3. So it means 1, 2, 3. So it's 0.003. Now your ppm is 0.003. Because there's a slight changes lah. So I also confused.
Oh, so when I got 4.1 million.
Yes, all okay. Now we below already. 4.1 million I get 0.2. 4 million I get 0, still 0 lah, 0.003. Just now we didn't open fully, cannot see. Because it looks like, now it looks like 3, right?
Yeah.
Yes, I was confused because when in the program you can see, that's why. You go to your program, main routine. Here, the 3, right? Then only I realized, what about 3? Yeah, but this is all okay. It's not 3 point something, it's a 0.002.
Okay.
So this is 3 way to calculate. Okay, then now my idea is I want to move this temperature value to this PLC. I mean this concentration value to this PLC. Okay, how? Okay. So you go to go offline first. Can I erase this?
Yeah.
So this function called produce consume. Yeah. So it's like this. So it's called produce consume. One must produce the tag, another one is must consume the tag. Okay. So your L73 going to consume. So this one going to produce. Okay, what we do? I can only produce integer double integer. Real I am not sure. So what we do? Go to control tag. Go to edit tag. I add one. I do one. Okay, name put produce. Okay, right click. Right click. Edit. So here the type. Okay. Click produce. Produce. No need connection. Actually, click here. No connection. Just can choose how many consumer can use. Maximum consumers lah. No one. Because one you want to use. So put one. Click. That's all. Double integer. Choose real. It should be real. Okay. So this one produce. So but no alias nothing. So what do I do? Okay, go to main routine. Go all the way down. I want to use move function. Right? Move. Okay. Move the first concentration or any concentration lah. Move to the produce. That's all. Okay. So means I just create one tag. I make this tag as a produce tag. Means any consumer can take this tag data. So here I do until here. Okay, save download. Okay. Nothing. Okay, minimize. Okay, finish already, right? Okay, minimize. Okay, now here, right? Here, I consume the tag. So to consume the tag, first I need, because all these are connected using Ethernet, right? Okay, what I need to do in the L73, I mean the consume PLC. I need to add in the configuration. I need to tell this is the produced PLC. So in the Ethernet, right click, new module. So in the Ethernet, I need to add this one. You search for L32E. Okay. Yes. Create. Okay. Okay, name you put produce PLC. Oh no, you put L32E PLC. L32E PLC. Okay, what is the IP address? Put this L32 IP address. Yes, that one. Okay, good. Now, click here. You put the consume. Let's put consume. But you can put any name. No problem. Okay, right click, property. Edit consume property. Yes. In the property, I need to tell I want to consume. Click here. Consume. Go to connection. Okay, who is the producer? Okay, what is the name in the produce tag? Is the produce, right? The name, put the name here. Produce. Must use the same name. Go to connection again. Go to status. Oh, I think can use only double nothing. Okay, later in the produce will change. Okay, that's all. So means here I create one tag. The tag name is produce. That's all. But here when I create the tag consume, then this tag I need to choose the PLC L32E. Okay, what is the tag name? Produce. I need to link.
What happens if they have a duplicate or similar name? No, cannot get the tag cannot have a similar name, or they will show error.
Of course, here I cannot have a similar name.
Oh.
You put another name, then only get delete. Put consume one. Just put consume. No, cannot delete. Put consume one. And then only can delete.
No, it can be.
You click at the end. Yes, okay. Now you download this. Save download.
So Siemens also have the same concept, right?
Same concept, but they have no need to do configuration. They have like a function block for that. You choose the drive, the first one. Yeah. Open. Backplate open. Choose the L70. Okay, download. Okay, now we go back to the other program. We change to the double digit. Okay, what I do, go to, so you won't get 1 point. Okay, you try it. I think you won't get the value there. In the other PLC, go to monitor tag. You won't get the value because two different, right? Okay, so in the other PLC, you go there. Okay, go to controller tag offline. Go to edit tag. Produce, change to double digit. Okay, download. So, but in this PLC, you only get 1, 2, 3, 4. You won't get in decimal point. Want to get decimal point, can need to do some calculation lah. That's all. Okay. Now go to monitor. Go increase. Increase the value. 0 means 0 only. Go up. Like 10, 20. Here 5, 6, 7, 11. So this is the value you will get in the other PLC. Go to the other PLC. It's 10. Thank you. You increase that. If you want in decimal point, can do, but need to do calculation now. Because that is because here it's, let's say 12.25. the same value you want to do. So what you will do, this number need to multiply 100. So you will get 1225 because this is in real. Right. This one can be in double integer. This value you move here 1225. Then later can divide 10 inside here lah. So 12.25. So this way right. So now here is 12.25, which is in real. This is normal tag. Just multiply 100 get 1225, which is double integer. This tag you make it as a produce. This is the produce tag. Then when you go here, so this consume tag 1225. This is the consume tag. Then this one can divide 100. Then you will get 1. This will be your concentration. So means from the concentration here, this is the concentration. This just a little calculation lah. You want accurate numbers, or you want to use 2 decimal point, or just direct move like this is okay. Even the same thing, I can move this concentration there also, the same way. So here must be become produce there. So now this guy produce, here consume. So if I want to do that way, this one produce, this one consume, the same thing. But in the L73, because in L73 right, I just add the L32E finishing, right? For this you add this PLC, done already. But for this, if you want to add this PLC, you add the module, then add the power supply, the PLC, then only can do. Okay? Okay? didn't do any program here, right? This PLC can do, you can get, this one is very common function. This function is, they call get system value. Means you can get the value of the system. Like what is the time or error or something, status, all that. Okay? Try to do one. That one will be under input, output, I think so. Yes. Click GSB. Yeah. On enough. On enough. Okay. Get system means get the value of the system. You want to read that. So class name, you click that. So what you want to do? Go down. Wall clock. Let's say I want to read the time. Okay. Then attribute name. Okay, what from the wall clock time, what you want to read? Double click. Okay, click that. Go down. Local date time. Yes. Okay. And what the destination? Okay, never mind. For the destination, we go and create here. Go to control tab, go to edit tab. Okay. Click here. You put date time, for example. Date time. Okay. And here, click here. Group up. How to do it? Group up. Go down. Array, because I want to use array. Just put int or int integer. Okay. No. Int in the bracket. After int, you put the square bracket. Can you see a square bracket? Int square bracket. Where is it? Okay. How many? Means like I set. Means I choose a set of values. That's what we call this. This is called array. Okay, means I read a set of values. Okay. So what the data I can take from the wall clock timer? The day from the year, month, day, hour, minute, second, millisecond. So 7. Okay, you put 7. 7. Okay, close bracket. Okay, means I have 7 data lah. Okay. You click open this. Okay, so it will be this 7 data from 0 to 6. Okay. Now go to main routine. Okay, now in the destination, double click. Click here. Choose this date time. Yeah. Date time, the first. Choose the first one. Date time plus. Okay, choose the first one. Yeah. Okay. Oh, why? Is it double? You right click. Verify one. Must match the. Oh, okay. I think must be double integer. edit tab. Change integer to double integer. Just put in front D. Okay. Okay. Now you go and check the main. Okay. You see no error. Means the data will be stored in W. Okay. Now save download. Okay, you go to control check. Monitor open. Yes, this the time is 1998. You can change, you can update the time. Okay, there's two ways. One way is same function we can use. Okay, go to offline. Go offline. Okay, go to edit tab. Okay, you add one more. You put set date time. Set space date time. Date and time. Okay, same. Double integer 7. Okay, now go back to the main routine. Okay, you add another one. Yes, this one is a SSV, set system value. Okay, what the same thing? Wall clock time. Attribute same, local date time. The source is set date time, the first one. Set date time. Go down, all the way down. Yeah. Okay. Save download. Open this. You can set the time. What is the value? 2025. Enter. Okay, then September 9. We put 9. Now the time is 2, means 14. Then 42. Okay, enter. set the value, we can get the value. Actually, what I've done is we must put interlock. Go to me. Need to put something because now it's like overwriting my original value. Put double click here. So just add one normally open here. Favorite. Okay. Normally open. Just put a new name, set data. Set underscore data. Okay. Right click. New. Create. Okay. Then this one. Yes. Okay. Finalize. Okay. Finish. So means one time set enough already. Go to controller tab. Now you see. Just now you see the seconds not changing. Here can you see now it can change. Earlier cannot change because always this number move. You can use this one or there's another one. Click here. Yes. Controller properties. Here also can do where's the date time here. Okay. So now this time lah. Earlier not this time lah. Earlier different timing. sometimes you have like this, right? Not produce. Sometimes you have a concentration 2, 3, right? Sometimes we don't get a proper value. So we want to see the calculation or something, right? Okay, so what you can do, you right click here. Let's say that this value is not accurate. Okay, can you see? Cross reference. Click that. So it will show I'm using this one at this place here. Okay, destructive Y. Y means is the output. N means Y means yes lah. N means no. So destructive means is it means it's a right value, right? Okay, can okay, double click. So it will bring to this place, right? Okay, now open. Okay, now so we know the data is from this block. Okay, so if you want to know what is the calculation of this block, you can go to the analog, this block. Okay, so once you know the calculation, okay, it's from where I get the value. AI channel 0 and local 3 what? Channel 0 data. Means from the local 3. Local 3 is what? If you go here, you can get local 3 is what? Yeah, you go down. So local 3 is your analog input. So analog output also same thing. Okay, so let's say you want to do for analog output. Actually, I can use this, the same analog, but I mean the name only. I think I need to change. Then I can same it. But the analog output, you need to set the value. That is analog output. Analog input means we receive the value. So yours is mostly analog input, right? For the 22 here. Mostly is for the gas concentration.
Yeah.
Temperature. Do you have temperatures?
Mostly is a concentration for
For the gas concentration, right? Means your company have your own sensors, is it?
Yeah.
What kind?
Not own sensor. It's not our own. It's we buy from factory lah. We got few brand lah. We are not carrying only one brand. You can see Honeywell or Restaurant or Honeywell lah. Majority is Honeywell.
Honeywell.
Many type. You need to see which type.
Yeah.
They have a different application, the different industry.
Different industry, different values also, right?
Yeah.
For 40,000. Okay. Any questions? If no questions, we can end the session. Anything you want to ask regarding Siemens also can? Anything you want to ask regarding Siemens also can?
If you got time, you can rehearse a bit back to the old one.
Okay. Oh, we have time. Which one? All this.
No, start from like how to use a counter.
Here, in this one.
Yeah.
Here.
Same.
Yeah, you same. Counter here. Okay. Can use. Counter.
Counter.
Compare we use already, right?
Mm.
Compare done. Move we use already. Max function use already. Scaling done. Numericals output is easier. Okay, you see one counter? Why not? Maybe you go offline. Then go up. Okay. In the middle area. Go down. All the way down. Okay. Add one line. Okay. You add CPU. Okay. So for counter, we need to give a name first. So can be any name lah. So just put any name there. Counter one. Right click counter one. New. Okay, great. Yes. So what is the value? How much you want to set? How many count? Let's say 3 enough. But we don't have any buttons. So just put 3. Okay. So must have an input count. So we just use a normal add. So add a normal open. So you just give it a name like a sensor. Right click, bring new. Bring new here. So just use a normal. Okay. Okay. So what happened? Very simple. Every time this one on, okay, now cannot because we need to down. So this one count up. Okay. So we can use the done. Okay, never mind. We use one. But you put toggle off. Okay, you add one more rung. Here normally open. So the idea is every time the sensor on, counter will count. Once I reach the 3, maybe I want to on an output, for example. So the 3 is result of counter done. So you click here, you choose the count, double click, choose the counter done. Counter open. Here. DN. Yes. Okay. So counter done, then one output. So you click one output. Just put a name output. Right click, new sentence. Yes. Okay. Finish. Wait, still got something. Once the counter finish already, right? So if I want to count again, it will reset. So add one more button. Just put normally open. Put a name reset. Okay, right click, new. Then, okay, go to counter and can you see reset? Yes. Reset what? Put the counter one. Yes, finish now and now. Toggle 0 back. Once history is done, right? Now we need to reset this. Press on this. Yes. Go back to 0. So what we learned is go back to 0. I mean toggle back. So what we learned? Very simple. How the counter work? Every time this line on off, I count 1. Okay. So means in front it can be anything. Normally open, normally close, compact, and anything. Okay. Once done, then I can use the counter down, done, and here can be anything. Can be a timer, can be a move, can be a scaling, right? Can put a counter here, compare here, output can. Okay, latch, unlatch can. Okay. Now, so what's the finish? The function of the counter finish. So means, so normally counter is not like only one count, correct? Maybe second time we run the machine, need to count again, right? So need to reset. So how to reset? So here we just do a normal one. So who want to reset? Can be anyone. The thing is, if If the line is energized, I will reset.
If I want to put auto reset,
Auto reset. Then
so the reset,
when counter done, direct reset.
so if I put here,
Yes. But now cannot because it's online. But you only able, it will only able to count 1, 2, 3 reset. But you can see the number 3 lah. Very fast reset.
if after 3 reset,
After 3 reset.
accumulate, is that one is a call to
Okay, if you want to do after 3 reset, can also.
is accumulate? No.
Masuk compact. Okay. Okay, let's say here. You delete this.
If I
Okay, never mind. You online first. We see the counter can count up to 4 or not. Online. No. Even though I didn't do any changes, right? I add and delete something. Okay, bring it down. Yes. You go up. Okay. Sensor one count. On, off. On, off. Then I can use the 4 to reset. Or I can use the 3, put a timer after like 2 seconds, automatically reset also can. It's just based on how you want to do program. It's the programming. So when you want to reset?
if we put after 3, 4,
After 3 lah. Okay, means more than 3 lah. So you double click, you can off. Okay. Double click here. Reset can take out. Delete. Just delete, reset, or just want to leave it also can, no problem. Okay. You click here. Go to compact. Yes. Greater than. Again click here. What is greater than? Double click. Choose counter 1 accumulate. Counter 1 here. Accumulator is more than 3. No, that one means source B. Yes, 3. 3. Because I'm choosing more than. So when it become, I will reset. Okay, finish. That's all. Finalize. Yes. Then now become 0. Right. Okay, again count. But must have 4 counts. 4 times the sensor must be on.
After 3, then you start from 1.
Yeah, because you know why? It reset, right? Reset and this one is on, right? So it will become 1. Unless I put a pulse here, then it will become pulse only, yeah? 1 count only.
So, by usually what we need to do is, first thing first is actually in the SLC500, we need to start is to create control tag as a database, you see. Control tag.
Yeah.
So,
Once we do the configuration, first we do the configuration. Once that, then we can do this we didn't link to any inputs, correct? Only this one we link to input lah. That's why we add this because all these are like internal memory. So if you link, then it become a physical input, physical out.
So what is a program tag? Is there also SLC500 also have this program tag?
Yeah. So this program tag is whatever we do inside here, we can put the program tag here also. Like why? Because we go offline. Because under main task, right click, new program. Okay. Let's put program 2 for example. Then here also I can do some add right click here, program 2, new routine. Okay. Main scaling, because main is only one lah. Main always one only. Okay. Now program 2, okay, let's say control. Control assistant. Okay. So here I have one. Right. So means I can arrange my program. So maybe under here I do all the functions related to your calculation systems, and here I do the connection with the PLCs. So whatever program tag I create here, I only can be used inside here. So let's say under program 2, now here I got so many routines. This program tag can only be used there. For instance, say this program tag can only be used inside here. Controller tag means all the blocks, all the programs can use. That is
Then this subroutine is only here. It's only belong to here.
no. Even I can create another one and I can call the routine there.
So if we create here,
It's another one. It's another program.
but can we call the subroutine here? No.
No, I don't think so. Double click. JSR. Enter. You search for scaling. Double click. Click arrow. No, don't. Cannot. Because whatever you do, because there's a main task here. Whatever you do here, only can be called in the main routine.
So when
Or
we,
some other routine also can.
sorry?
Some other routines also can.
Some other routine.
Yeah, it means, okay, can I erase this?
Yeah.
So it's not necessarily must be the main. Okay, can you see in the main there's a 1? No, in the main the picture that there show put 1 number.
This one?
1. Here, small one.
Oh. Here also one.
Yeah, that is another main routine. That is for the program 2. Okay, now you see.
Oh, if I put the.
Okay, you put another routine. Okay, second.
Okay. Invalid.
Because of what underscore. Okay, so here right. For this program. Okay. So you see, I have made routine. So this is create another routine. That is, let's say for example, second. Process, for example. Then I call here in the main routine I JSR. Okay, under the process. Let's say I create scale, for example. Okay, then I can call it. Then here it can be function block or ladder, is depend. Let's say I get another one. Let's say auto control. I call in the main, and inside motor control I put another routine. That is the one is for the motor 1 functions, one is for the motor 2 functions, and one other one is the settings. For example, all these can be called inside here also, JSR. So means it's not necessary any routine you create, right, directly called to the main. No, not necessary. It can be called in another block, another routine, and this routine must be called here. You cannot, you call here, then this one didn't call, of course this program will do. Because somehow need to go to the main, because why? My CPU only will scan this PLC, this main routine.
So here this unscheduled program means is not need to call.
Need to call, yeah.
So in this main program, once you on the CPU, they will scan this.
Scan this.
Main.
Inside here, I do JSR process. Then I go inside process, scan.
So in this structure right now here, so the program 2 will not scan.
Scan because will be in the controller 2 also. Controller also is the main routine. Yes, that's also. So if you scan both main routine and also the controller together.
No, sorry, my question is, if I look at here, once I on the CPU, I thought you only call for scan main program.
No, main and program 2, both.
So it's main task like you will scan
Yeah,
all the subfolder here.
Yes.
So
yeah, under this one of course main task direct go to the main task. If you go under the main task, under main task, okay, go to the main routines.
So basically we need to set the hardware. So the main routine inside you can have a process scaling.
All these are different routine. So if we use the JSR so JSR here, JSR here also, all these will be in the main, right? Now inside here, JSR. So the logic is here. Our logic will be here.
So the purpose of the split to JSR.
The purpose of this one main routine. This one what they call subroutine to arrange our program.
To arrange actually there is nothing related to the function, but it's more toward
FC It's all called FC.
how we arrange
FC.
the FC, the function we also can write in the main routine also, but just main routine not supposed to call all the program at the same time.
No, okay. In the main routine also, whatever program here, I can do it here, no problem. Still can run. But where it will be difficult, and we do programming also same, troubleshooting. So just want to troubleshoot only the motor settings. So you know, inside here what say I can straight away go here and troubleshoot. If all the program put it here, very long. The older systems all like that. Like this small Mitsubishi Omron still okay. Small Mitsubishi if you using, but they also have structured program, simple program. Using simple program can go up to like hundreds of lines, all in one main. They don't have this FC or they. .fc they call routine, another routine, that's all.
I didn't bring. Yeah. Cause last time I forget already. Here got this. It's a SLC500.
Yes. Yeah. One. Yes, still.
So the data file is belong to configuration of the hardware. This end.
It will be similar. Which one?
This one.
Okay, this is similar to our controller tag.
Oh, controller tag.
But the difference here is, here they already fixed. Input means I, right?
Okay.
Arrange. Okay. So here they fix. Input means I, output means O. System bit means is S. Right. Timer means must use T. Counter means C. Right. Integer is N. Then you can add lah. Which is supposed to add float everything. But in the 5000, they don't have the address. You just put a name. You go to the 5000. You see the 5000. You go to you open. Go to any time. Very simple. If you put all these supposed to be, all these right, actually, all these real, right. Here must be N8 or N9. Must be real, a new one, okay. Integer means here must be N7. Here AI, right, will be I1. But here don't have. Here, if you put a name, put this one, okay, become a memory. If you alias, I become an input. That's all. Because inside the 500, for each one they have their own numbers, own addresses. So they don't have like a controller tag. They call these data files. The rest is same. Here also, can you see? Main, then timer 1, max, counter. You go to the main, do the same thing, correct? Jump to subroutine. JSR. But you cannot choose the name lah. You just put U3. 3 means okay. Ladder number 3, ladder 4, ladder 5. like this, timer, right? TON, right? You put T for, because you follow this, for example. Counter means C5. But there, just put name timer, it become timer. Just put name counter, data type counter, it become counter. So it means no address, just the name only.
Sometimes I was confused like the function when we have a branch.
Yes. Why branch, right?
Yeah, how?
When to use branch?
Yeah, then the push button is usually people all do this, right?
Yeah. Okay, why?
How the?
Okay. It's depend on actually your output. Okay. Let's say output is motor. Motor is not directly motor, relay, contactor, anything. Now, when I want to on the motor, let's say for example, I press the push button, I want to on. So this is the start P. I press, so the signal goes, energize. If I release, there's no signal, cut off already. Okay, but the motor I want to be like always on. I press that, I want to continuous running. So I use this as a normally open item. Okay, why this?
How the electric?
Yes, okay, because earlier before PLC, because ladder is from the electrical diagram, right? So this is 24 volt. We use a normally open push button and a relay coils. This is the 0 volt. So when the relay gets the positive, negative, relay will activate, right? So I press relay activate. For release, relay will deactivate. If I want to hold the relay, how? Relay have coil and also contact. I use the relay contact, the contact from the relay, then I use the normally open contact, then connect back to the positive side. So what happened? So here is the 0 volt, right? So here the current will. So I press, so the current flow, energize the relay. So when the relay energized, this one also close, right? The current will flow like this. The moment I release, it will cut off here.
Yes.
But it's still on, holding. The same concept here. So here,
What the thing make the R1 hold?
hold. Because I'm using the contact to on the plus again. Because the idea is very simple. How to on relay? Give positive, negative.
Yes.
Negative already done. Positive earlier from the push button. Now I get the positive signal from my contact itself. Because I look back.
Yeah, so look back.
Yes. I take the output. I take the contact. I connect back to my positive signal.
So it become like close loop.
Yes. It's the same concept here. So when I press start, current flow and activate this. If I activate the motor, wherever I use the motor, every place will be on. So here will be on. Maybe below there, I use another one. Example lah, motor. Then here will be on. Let's say another one I use normally closed. So earlier it's normally closed. Now I cut off already. Then when my PLC go here, he said this one on. Okay. I will flow like this. Continuously here. Then here I will on. Here I will cut off until here. Okay. Then let's say I release. Release. So the current from here cannot go in until here. So this one signal will still flow. Okay. So if I want to off motor, I need to put something here. It can be normally open, can be normally closed. Depend on your switch type. So let's say our switch is a normally open type, means I press must be on. So here I put normally closed. Stop. So normally closed. When I stop, cut off. So when I press, cut off. So when cut off, this one will off. And this one off. Off here. So here off, here off, here normally close. Because normally close right here, here. Okay. So this one off. Okay. You cut off the latch, and let's say the push button I release. So now go back to normally close again. Okay. Because motor off already, right? So normally close again. So here we cut off. Now here can give. So it just need to play with the normally open, normally close. This is a, if it is a push button. Let's say I erase this.
I think.
I want top only. Top. Let's say I do another one, like a sensor.
Sorry,
Yeah, okay.
okay.
Okay. So let's say it's a selector switch. On, motor on, off, motor off. Say like our button here. So let's see. Like a switch. I on. Motor on. I off, motor off. Then for this I don't need to do the whole thing. Or we call it latching.
Straightforward, this one.
Straightforward.
Push button need.
Push button because I want it continuous on. So what I can use? So I can use the same address here as a normally open, so that when this one on, here can adjust. Then I connect.
This is the logic. So for the hardware itself,
Hardware you need to do any wiring. Hardware is the same thing. In the hardware side, all your input connect to your input, all your output connect to the output. That's all.
no need to look the wiring.
No need. That's what we are doing inside the program. That's what we are using the PLC here. Because earlier, they doing like this. Okay? Then they use, example, want to connect on a motor. Then they use the same relay, another contact. The R1, okay. Maybe this is a live. Okay. Go to the motor, for example. Then this is the neutral. Because the same relay can have sometimes we will have 2 contacts, 4 contacts, right? Okay. So the first contact I used to loop back, continuous channel. Second contact I used to the channel. So my PLC idea initially is to take out all this relay. I don't want relay. I want directly go to the channel. So what happened? This is the PLC. Connect 2 push button. Input 0, input 1. This is input. Now, this one now go to the motor. That's all. No other thing, no need to do any. Wiring is very straightforward. All your input from the field device, all your input go to your input. All the output from the PLC go to the field device. That's all. In the program only we can do this etching lah, looping lah, so many interlock, right? Let's say here, sensor 1 must be on, sensor 2 must be on. Means I have additional sensor. So only will be additional inputs only. Can be normally open or can be normally closed. Right? See? For input controlling one of them. If you don't have the PLC, then only you do something like this wiring. If you have PLC ready, the wiring idea, the logic, you put it here. Here just normal connection. That is the PLC function. That is what they created the PLC first. You know for what they want to put each other. Okay. So you see I start, right?
Start.
Press start, a motor run. Then this one BI is from where? Right. No, here.
Oh.
So if the data A source A is more than source B, I on this, then I use this to cut off my motor. So it can be that you don't know la data 1, data 2 lah here.
Because all these normally close, so the current will on.
On.
But actually this is, but here, how do I know this is a push?
Push button or not?
Yeah.
Here you cannot know.
So for the TIA portal, I see there is a coil, the P, a pulse.
Pulse. That is the pulse we use. I think we use.
So is it the P is a stand for pulse, right?
It's a pulse function. It's not for push button. It's a pulse function. So means, let's say for example, like this. This one is always on. Right. When you turn on the switch, it's always on.
Yes.
I don't want the signal always on. I just want one pulse signal, like on off. I want to use that signal. Then I can use that signal.
The pulse.
The pulse signal. So for this, I have a ONS one in the beat. Under the beat. Yes, sir. OSR, ONS. OSR is the P, OSF is the N.
OSR is stand what?
One shot rising.
One shot rising.
Rising means positive.
OSR. So it's similar to the TIA portal P.
P and P. N means is falling. They have a
OSF. ONS.
ONS is one rising, same like the P.
ONS is
same like the P, and OSR also same like the P. OSF is the same like the.
So here, based on this ladder here, why don't just use OSR easy? It's not correct.
Not correct, because this start button, according to this one, what I see, this start button is already a push button.
It's already push button.
Already a push button, because that's why I latch it.
Okay.
Correct. Even though they didn't put the name here, when I see, okay, it looks like a push button, because we don't know how they're going to do the wiring. Inside here they can put like this. Then actual wiring they can put selector switch.
Yeah.
If I select a switch, then this program wrong already.
Okay.
Then I can put the OSR.
Okay. So if it's a selector switch, you can put OSR here because no. If selector switch just put on easy.
That one as you say, it's all depend on the program, the logic.
Also can put OSR.
Yes. Depend. That's why I say depend. Why? If I want to leave it at this, leave it. Let's say I on the switch, the motor on. If any sensor on, I want to off the motor. But the switch must be remain on. In that case, let's say I want to put the sensor to off. Right?
Yeah.
If I do like this, of course cannot off. Because sensor is like an example. That's why I say all these are logic. Let's say the sensor is just give like one signal, on-off signal. So I turn on ready, the motor on. If the sensor suddenly triggers, motor off. So that is the idea. So I on, switch on, motor on. If the sensor trigger, I off. Okay. Now, but the sensor is not like always trigger. Just like one signal impulse. So in that case, how it works? Sensor normally close, right? Sensor on, okay, motor. When sensor trigger, the moment it trigger, okay, cut off the motor. The moment it's the sensor off ready, then we on back, correct or not? Because it's on. Let's say the process, the program should be, I on the switch, I leave it on, motor continuous run, and the sensor trigger, motor off. So if I want to on again, off, on again, for example. In that case, then I cannot use this way. So what I do, I need to make this as the ONS. So ONS, the function is, it will take the signal from the front and the back, it just gives the pulse only. So means that now these two together, right, these two combined together, it become like a push button concept. So I need to latch it. Now in this case, okay, I latch after here. So what happens is, the moment switch from 0 become 1, I give signal to this guy. What happens? This guy will give one pulse only. It means I send on, then I off. So now this one is similar like your push button. The whole thing, not only this. So if the sensor trigger can cut off the motor. So sensor trigger, cut off. That's all. The motor will be always off. The moment I off the switch and on again, then again this guy will give the signal, the pulse. The idea is, the main thing what we need to understand is, we need to understand how the coil work. How the coil work, very simple. When I get signal, I on. When I don't have signal, I off. How the ONS work? ONS is, when I receive, I give only pulse. Then it's a positive, means the front one must be from 0 become 1. How normally open work? When there is an input, I become close. And though there is no input, I open. If normally close means, when there is no input, I off, I close. When there is an input on, I energize or open. That's all. You need to understand all these functions. Then it's easy to do the program. But need to practice. So that's why I say wiring is just straightforward. There's nothing to do with the wiring and our logic. Wiring is how many inputs we have, how many outputs we have. That's all. Direct connect. In the logic only, okay. For motor 1 maybe 10 seconds. For motor 2, yeah, I use the temperature to control. So your VPN, okay. When I reach the VPN, cut off the valve, all that. Just need to know how to use the coil, compare, counter, timer, all that.
Infinity. Here, okay, for Siemens, I don't know what is the purpose. They learn the data map address, like one binary address, 1011, like hexadecimal. From the number, they can know where is the address of the card and the point, is it?
Okay. I know
You know what?
I 0.0.
No. They got one hexadecimal address, like they got numbers and the memory map. So they got numbers and the alphabet. So from there they can know what is the card. Like
You have any example? Any picture?
I really don't have. Like watch table, when they open the watch table in the TIA portal,
They can change
they can see.
change the format, is it?
Yeah.
Decimal, hexadecimal,
No.
binary.
HES, Siemens HES. Okay, examples that they mentioned is they start from 0 to 9 because like 16 bit address is 0 to 9 A until F1.
Okay.
Right. So in the watch table, if example they see 4A03, then that means you know how to convert to become decimal, then where is the address? Is it that is the question? I also forget already the
So
SL
you have the picture, no?
I don't take a picture. I just try Google. I cannot find the same question they ask in the exam.
Okay, what in the exam what they ask you to convert the
I want to locate
Hexa?
the from the hexa they give.
okay
How to find the
Find the what?
value or the address? I can't remember.
Address cannot find. Value
Address
can find.
Value can find.
Yes. Address cannot find because Siemens won't work in that way.
Oh,
Ah,
am I wrong the question?
yes. Because Siemens addressing, it won't work that way.
I don't know. Related photo is not the question. I send you one.
Okay. This one is the memory. How the memory works, how the memory forms.
How the memory form. Because by example, you see they give some examples. Not this one.
Okay, this is the data types. Okay.
This one. But got one exercise I show you. So the exercise I don't understand is in all three examples the light should be on when S1 is activated but X2 is not activated. I send you the last one.
Okay.
So on top is a hardware, bottom is software. So is the question, okay, the scenario in middle, S1 now look like it's a normally open, and S2 is like normally closed.
Yeah.
So in the logic ladder, so for this both switch is normally open or normally closed as you put. I get the answer thing wrong with this. So the scenario they ask is when I press S1 and the S2 I did not press, it's not activated based on what he said. So which means I leave it normally open. So S1 also normally open, not correct. I give 2 normally or 2 also not normally open, is it not correct? I forget the correct answer already.
Okay, what is it?
light is a Q4 ah.
Not activated. Okay. The first one is correct. Second one, normally open. Okay. Third one, yeah. This is what you did, is it? The cross you did or what? This is funny.
Because the below one I suddenly counting one. But right, the question paper when they come is all they put blank one ah.
All they put normally open.
Yeah.
Yeah, but you put correct one.
So
All the letter, all the three letters is correct.
middle all is a diff normally open. Then I remember they said wrong eh.
It's not activated, right? So when because S1 is normally open, so when you press, I want to send a signal. S2 is normally closed, right? So the signal is always there. So both must be normally open. The second one, not middle one.
First one need to press. Why is not normally closed eh?
Which one?
Middle one.
Very simple.
I'm confused already.
Can I use it?
This is not my good answer. This is you tell me. So in the picture now, the letter here is all correct.
According to the picture, yeah, correct. All what you put is correct. Okay. This here, very simple. So there's two input. One is normally open. One is also normally open. Okay. This is the S1, S2, one output. Okay. So we put L1. Okay. Very simple. So when I press the one, on. That's all they say, right? Did they say need to hold or what? Nothing.
No.
The light should be on when S1 is activated, and that's all. They didn't tell me to latch or anything.
Yeah.
So when S1 on and S2 not on, right?
No.
So because it's normally open, when I press, then only here can be closed. So I put normally close here. Then the output L1, S2. Okay. If one is normally open, another one is normally closed.
Yeah.
S1, S2, here the
This is the hardware.
so when S1 press, so must be same thing like this. Normally open. When I press, then only the signal go through. So here. So how it goes? So when I not pressed, signal goes here. When I press here, on. In this case, when I press this again, on. So S2 they say not pressed. So means the signal is always on, right? So if I put normally closed, means it will open. So I leave it open.
Why we put normally close if we open it?
Yes. So because you know
The hardware is already closed, man.
already closed. That's the thing. Don't confuse with hardware closed. Because you see, here both are open, right? But one I use open, one I use closed. Why?
Straightforward because you want
Not
to
straightforward. Why? Because
you give
when
current.
I press this one, I want to set the signal. For this one, when I not pressed, I want to set a signal. But here, opposite. So when this one is not pressed, means this, but the input is already in. The input is already energized, right? So if I use normally open, the input is already energized. So when I press this, it can on. When I press, only the input will break. Hardware and in the program is different, totally different. Don't always confuse hardware and the program. Hardware is how you need to read is if did I get the input or not? That's all.
Okay. If the hardware, the switch, they are already normally closed.
Means the input is already on.
Yeah, it's already contact the current.
Yes, there's a
So why we want to put the logic to the normally
open.
yeah, we supposed to put normally closed one unless we want to
Okay. First,
activate to
No.
unlatch.
no. You need to understand how the inside the program works. Okay. If I use normally open, when the input and there's a word input on, I energize.
Okay.
And there's no input, I
Gone.
nothing.
Okay.
Nothing.
Okay.
Okay. Now, how the normally close work?
When the current come.
When though there's no input,
Mm.
normally close.
Mm.
When there is an input, I cut off.
Mm.
Correct? Simple. So means here the input is there any input or not?
No.
No, for S2.
That's right. It's
Already on. So when I press, I need to pass through this guy. So I must put normally open. Because the input is already 1. We see 1 or 0.
So it's not the concept of the relay normally contact.
No,
It's not the wire contact. It's all.
Yes. Here, how it works? If it is 1, I will come first. If it is 0, I open. In this case, if I want, I open. If it's 0, close.
So which means if I put that normally close and it's the input, so it will on. So become break already.
Yes. So if I put normally close and the value is 1, so I cut off already.
So the answer is
Yeah, correct.
open.
The last one is the same thing.
Okay. The last one, the most switch is
Normally close.
normally close.
Okay. Same thing. See. Normally close. Normally close. S1, S2, L1. Okay. Both normally close, huh? The same concept. What they say, if I press, right? So, before press, there must be no signal. Correct? Means, cut off. Means, the value is already 1. Here also 1, right?
Yeah.
Okay. So, if 1 means there is no signal. Correct? Okay. This one from 1 becomes 0. Correct? Because I press right. So this one from 1 becomes 0, I can pass. From 1 becomes 0 means I can give the signal. And here it's same like this one, remember? Same like this one. So normally open. So because the value is already 1, because I want to go through, I want to give the signal. This one when I press, it becomes 0. So when it becomes 0, then I give signal. So the thing is, we need to know when the value becomes 1, okay, what you want to do. When the value becomes 0, what you want to do.
Because you cannot get away the memory with the hardware relay contact.
That's why. I know. Because you're already used to that value.
Yeah.
Relay, contact, right? But this one, we need to practice more practice.
My understanding is the physically hardware is already contact there.
Hmm?
The wire is there already. Contact.
Yes, yes,
Then only you give a signal to open it.
yes.
So now the last one scenario again, when now is 1, is the signal is 1. So when I press,
Become 0.
becomes 0. So the normally close.
Okay, very simple. I put normally close here, but when the value 1, what happened? I put normally close here. If the value is 1, what happened? Open.
Open.
Value is 0,
Close back.
close. But now value is, earlier is 1.
1.
So I don't want to pass through, right?
So it's open.
It will open value 1. So when value 0, close. So because when I press, it becomes 0, right? So I want to close. Then I
So
close.
your this one last. Hold on, come again. You one more time. When just how to say when the value.
Now you see, now the value is 1, right? I don't want to on the out L1 landline, right?
Yeah.
Okay, so what I do, I put normally close. Why? Why? Because the value is 1. So if I put normally open, if the value is 1 means I will close, I give the signal. Okay? Okay, tell me, I put normally open. What happens? If I leave it like this. Because option 1, there's a signal, right? So 1, there's a signal. So energize, right? So I'm not doing that. Okay, so what I do, because if you're using normally open, if the value is 1, it will close. Correct. So what I do, I put normally close. So if the what symbol is normally closed and the value is 1, it will open. Okay. So when you press this, the value becomes 0. So normally close. When the value becomes 0, go back to normally close. So you need to think like that. Don't think, because here also normally open, normally close, here also normally open, normally close, right? Always be confused.
Yeah.
So the best thing is you compare with the value. Here 1 or 0. So it's easy to do the normally open or normally close. And all this must what we do it right. We do it. We have the sensors. I mean the buttons, right? We just observe. It's better. Yeah, also. if you do like that also cannot. The best way is do it and observe. Sometimes we imagine also cannot. Even now also sometimes I imagine sometimes when I do program, okay, I imagine okay here normally close lah. Aku normally close. When I test cannot work.
Cannot work.
It's supposed to be normally open. Because sometimes we cannot imagine. That's the problem.
Okay.
The best practice is
So what is the purpose they want us to learn the memory table, the one just now, the very first one I said? What's the purpose they need to learn?
okay.
Bit, byte, word, double word.
Yeah, because it depends, right? Bit means boolean, right?
Yeah.
So, like normally open, normally close, must use boolean. Boolean means it's a bit. Okay. If any values, it can be like data lah, right? Let's say we use move lah, move. Move means data, right? So it can be word. First byte. But this will apply for all the models same. By word double word. Means this is the value lah. Move, compare all that value right. Okay. So very simple. So if you want to use in normally boolean right. Want to use this the memory as a boolean and because it's a boolean. Okay, 0.0 and so on lah, whatever. Okay. If output or normally close M0.1, 0.2 and so on lah. If you want to use as a byte word double word, because what is byte? 8 bit, 16 bit, 32 bit. So it depends on how big is the value. That's all. How big is the value? How big is the value? So example, you want to count, for example, counter, right? Counter up, reset. This is the counter will be in the Siemens one. It will be like this counter also, but our counter directly fixed is a double integer, 32 bit. Okay. Here they put. Here you can choose. Inside here actually there's a integer, short integer, double integer, which is similar to byte word double word. What's different is all these only positive values because 8 bit 1111 that is what we do. Okay. If all these 111 we will get one value right. Integer means can be negative positive. Byte word or means is a positive because all these will be in hexadecimal. That's all. Now here because here you do the set point right. This is the accumulator. This is where the accumulator. Okay. That's it. You choose short integer means byte lah. So must use. I put it here. Must use M B 0. If integer M W 0, W integer M B 0. Here don't have that. Here put name. You can choose double integer, all that you can choose manually. But here not like that. Here you need to choose the data type, then only the address. But what they are telling there is because inside here how many bit? 32. 32 bit means inside this how many word? 2 word. Inside word how many byte? 2 byte. Inside 1 byte how many boolean? Inside byte 8 boolean. Okay, so means the boolean from M0.0 until M3.7. How many bit? 32 bit, right? 32 bit means so inside MD0 is all these bits combined it form one double word. That's what they're telling you there.
So
correct.
this is the learn for when you want to set the database or control type or what?
This one is to store values.
Store value.
Yeah.
But this is a limited, depends on the I/O and CPU limit, right?
Yeah. But this one, small one can go up to 4,000 bytes already.
4,000 bytes.
Small one.
Yeah.
Means this one. If the 1,500 can go up to I think 16,000. 16 or 32,000. It's a memory caching there.
But later go back and I will try to install V18. Maybe I see any part of my try to I try myself see can install the V18 or
Yeah. Try to install it.
but your guys install never encounter the problem like that,
Which one?
The just now I show you what the black color.
No, I never got it.
Don't know what happened.
Normally I encounter.
But got virus or not?
No, I know because the PLC for me, right? I know because sometimes I also download most of the software I download from there only.
You see, so system track, etc. not handled.
Yeah, maybe I'm not sure what is the maybe version. The problem is I never used version 18 because I used version 14, 14.1, 15, 15.1. Straight away I jumped to 18. Because 16 I know it's not stable. 17 I know never because 16 I there's one time I do training for one guy from Australia, do online training. So he is using 16. I was teaching 15 lah, so no problem. But the moment whenever you use 16, whenever you do project, I will shut up. So I'm not sure. Laptop problem or 17, 16 problem. So
the only one very expensive, right?
of course.
Then also I'm not buy for
If you're using if you want to buy basic, means only can do 1200 program and the HMI, simple HMI. I think it's around 3000 plus Malaysian ringgit. But if you want to do for only PLC programming, around 11,000. But you want the PLC professional, HMI, because PLC, if you buy TI portal step 7 professional, you already get all the PLC model and the basic HMI model you already get. But if you want to do comfort panel, then another 6.
So for my case, right, I need to install TIA portal V18. Step 7 also need to install.
No, it's already together.
It's together.
It's
But
actually
I see the website we need to download separately.
No. Actually, TI portal version, that is the whole name. If you go inside, they call step 7. For PLC program, they call step 7. For HMI program, they call VCC.
Yeah, VCC.
VCC comfort. So they combine both, it become TIA portal.
So I just install one enough.
Totally.
Then, or maybe because I install
you need to
two.
install 2. Actually, that's software I need for 2. One is you see TIA portal step 7 something.
Yeah.
Another one is a PLC Sim.
Yeah.
These 2 you install.
Oh, then the rest no need already.
Rest no need.
I also install, maybe cause the crash, is it?
Maybe something. So when you want to download 18, you just download. Or when there's a disk, you just take picture and send to me. So I will tell which one you install.
Because sometimes like 5 or 6 gig, so they download.
Of course.
Took sometimes in few hours. My
internet.
I did not select the Unify the highest one. I took 300 MB my one. So it took like 1 to 2 hours to download.
Yours is 300 MB.
Huh?
300 MB.
I think it's a 300.
Then why so long?
Yeah.
Because my house also mine is actually 100 MB.
Few hours I download.
Because in my house I download 5 GB one. Like 20 minutes, 30 minutes.
No, I see run like 2 hours. I don't know what.
Maybe
it's a 300 MB like my account. Fake one.
Maybe too many usage or what something. Or you can check the speed first before you download. Or maybe like that also because the PLC for me he upload in Google Drive, right? Maybe there's so many users in accessing the Google Drive. That one also be there.
Okay, I think so far good.
Yep. You can copy your files now.
I did not bring anything.
One pen drive? One pen drive?
Okay. version or same? Same.
Company
I
preference.
already-
Company preference is same.
Same one.
Yeah.
I already got.
Okay.
I'm not going to ATM.
Oh,
I'm going tomorrow because you see nothing to do. So tomorrow they call some Shafi is coming tomorrow. And they call other lecturers to solve the heating issue.
kilo.
No, I want to take. I can put a right.
Okay, thank you.
Okay. Sorry.
Huh? Oh, I haven't checked. Okay, check it. Go check. Keep in touch again. Thank you.
Thank you both.
Okay, see you.
Alright. Keep in touch.
Right.
I have to go and buy that mood.
Wow, this one's full already, bro. You got 1 GB left.
Which one? Oh, I think the recording on.
Oh,
I think the DVD.
where's the recording? Oh, this one, the one year.
I don't know, but recording.
Yeah, that's why backup.
No, the folder can delete.
Total 18 GB இருக்குது எல்லாம் இது project D1 lesson, D2 lesson, D5 lesson, D1. That guy left his suitcase in Birmingham,
Oh,
get in the bus,
you're not going there.
and then he realized that and he took another bus, drop off, took another bus, go back there to terminal, took the suitcase and bought another ticket. The already told him I was lucky to go drop him. That's when I carry anyone. Okay, you come and when you come down to the game, or you reach at around 7 p.m. there, I'll come and pick you up myself.
Yeah.
Yeah, what's the duty better?